All right, ready to go. Please give a round of applause for Hans from RISC Zero.
Thanks. Thank you. Thanks, everybody. Give it up for VM Day, Cartesi, Fuel. My name's Hans. I'm a developer at RISC Zero. We're a company that's trying to pioneer verifiable computing. What does that mean? Well, we have a virtual machine, hence VM Day, and we verify it with zero-knowledge proofs. Specifically, this virtual machine is built on the RISC-V instruction set architecture, and we utilize ZK Starks to prove that. We do that because the VM itself and the RISC-V instruction set is the circuit. This addresses the growing needs for privacy, as well as security and computational processes in a, in theory, decentralized way. It's ideal for applications requiring data integrity, confidentiality, and of course, that's useful in blockchains, finance, and a number of growing fields. So, how do we do this? Well, like I said, it's a zero-knowledge virtual machine. It emulates the RISC-V instruction set. RISC-V, if you're not aware, is an open source instruction set, recently developed. It's available on consumer hardware in a growing fashion. It's a reduced instruction set. So typically, CPUs are something like x86. These are just really complicated instruction sets. They have quite a few instructions. RISC-V greatly reduces that and allows us to easily implement and constrain the system for zero-knowledge proving. We support languages like Rust. In fact, that's a first-class citizen. It's written mostly in Rust. But in theory, this should work with any compiled language that can be compiled to the RISC-V architecture. There's a growing demand for RISC-V, and we hope to continue to see it grow. And we likely will, especially with the way chips work. Anyway, so the core of RISC-V and RISC Zero, zero-knowledge proofs. What are they? If you haven't heard, well, they're a way to prove data without necessarily revealing that data. What does this mean? Zero-knowledge proofs can validate computations without revealing the data or virtual machine state. We use ZK Starks to provide scalable, transparent, cryptographic proofs. Our design ensures that security is utmost, it's very important, and it allows us to ensure that the validation and integrity of processes carried out within the virtual machine are reproducible and verifiable. It's ideal for applications requiring integrity, so hence blockchains. It's easily integrated and verifiable with our start to snark, basically minifying the zero-knowledge proof with our Bunzai proving surface, which is just a bunch of GPUs. So how are we doing this, and how does it affect you? Well, our hope is to streamline this sort of execution. You write familiar code. You don't have to learn a specific DSL. You probably already want to learn Rust if you don't know it. And that's how we do it. There's various methods that go into maintaining the integrity of this. We use a couple of hashing methods to make sure nothing within the pipeline is actually modifiable without causing some sort of collision with the hashing. And so here's an overview. Basically, you write some code in the guest, which is the virtual machine. That's compiled to an ELF binary, put in an executor. Inside of this box is where this execution happens. This middle area represents an execution trace. In other words, what actually happens on the processor, where memory is written to, etc. That is proven, and you get back a receipt. So this ensures trust. It ensures computational correctness and integrity. Integrity seems to be a power word today. Yeah. Verification process confirms the integrity and correctness of that execution. It's essential for maintaining trust in the system. How is this useful? Well, shaping the future of secure computing. It opens a new era. It merges advanced cryptography with open and flexible standards, that is RISC-V. And it addresses the critical need for security and verifiability, as well as privacy in the ZK setting and context, which is incredibly useful for blockchains and finance and healthcare and any other sort of data-sensitive sector. So what are some of the challenges we have ahead? First, hardware requirements. Proving things is demanding. We have Bonsai, that's our proving service. It's a bunch of GPUs. It's not exactly cheap, but it's worth it. Virtual machine performance. Right now, the VM, the ZK VM, runs in the megahertz range. We'd like to see that in the gigahertz range. We're also constrained by memory. It's nowhere near as performant as your laptop or possibly even your phone, but that's improving day by day. RISC-V adoption. Well, RISC-V is an interesting thing. It's certainly being more adopted. It will take some time, though. Language adoption, package support, and developer tooling. Basically, learning Rust, learning other compiled languages, probably worth the effort. But hey, decentralization hasn't been a priority for RISC-0, but it's important. And of course, getting the word out. It's up to us to spread the word that these things are possible. You can use these snarks on-chain for verifying things on-chain. So it opens up a whole world of possibilities. Anyway, that's our QR code. Scan it if you'd like to have some more info. We look forward to your questions. Thank you.
Does anybody have any questions? I can bring a mic to you.
What are some of the use cases or applications you're currently seeing an interest from for using RISC?
Yeah, so the applications are pretty vast. I mean, you write normal code. You're not thinking in circuit languages. You're not thinking in special DSLs. You're not really even writing code that you would think needs to be in a ZK proof. You just write normal code. And that's pretty amazing because you can basically co-process all of that code off-chain and then post that back on-chain and verify that on-chain using Groth 16 verifier with the start-to-snark pipeline I mentioned. So it allows you to remove computation from on-chain, which is of course expensive and gas-intensive, and still have that in a verifiable way that anybody can verify. So if your program runs in, let's just say it's a really complicated program, you don't necessarily want people to have to rerun that either. So they can just verify the proof, sublinear time, and it's pretty useful, especially when you want to put stuff on chain. We have a couple of applications that we've actually developed in the last couple of days that demonstrate this. You can check it out on our website or Twitter. And one of them is Bonsai Pay, and it's using the Bonsai proving service to generate proofs that are verified on chain so that way you can send crypto to your email address effectively. It's pretty useful. It unlocks a whole world of possibilities. Anyway, next.
Cool, thank you. One question, if I want to run a Bonsai prover myself, how much GPU do I need?
Well,
or how little do I need?
You can run it off of your probably consumer grade laptop. There's a time constraint here though. People don't like having to wait hours. So The Bonsai proving service runs on anywhere from 50 to 100 GPUs. I don't remember the exact GPU model, but that usually reduces a few billion cycles down to a couple of minutes.
Okay, we have time for one last quick question.
I'll make it quick. So compared to a DSL, if you write your circuit in a DSL, intuitively, I would think that it's probably more optimized.
Yes.
How do you see that for the future of RISC-0? Do you see that? Because I kind of see that as if you're writing something in production, go write it in a DSL. If you want to do something fast, easy, write it in RISC-0. How do you, any comments on that?
Sure, yeah. So there's definitely a performance difference, and there likely always will be, but we're focused on general computation. Having a DSL, well, it might be a fully featured language, it's often difficult, and you need specialized people, and you need specialized talent in order to do so. This removes that. I'd say it's sort of analogous to like ASICs versus CPUs. What won in the end? CPUs.
Okay,
Yeah.
I think we have to wrap it up. Thank you so much.
Sure thing.
And we'll see you on the panel.
Thanks,
after
everybody.
The lightning talks.
Thanks. Then keep on the applause, please, because we got Kautuk with Stackr. You're going to tell us something about the next generation of virtual machines. There you go.
Hello, everyone, and yeah, thanks so much for having me. Just waiting for the slides.
We need some elevator music. Only the Americans get that. Okay, there we go.
All right. Yeah. Hey, everyone, I'm here to talk about Stackr. So we're building a micro rollup framework that allows scaling Web 2 and Web 3 applications. So before we begin, everyone talks about like where the rollup is deployed, what exactly is a rollup, are rollups real or not? But I want to start with like, why is a rollup? Like, what is the purpose of rollup? Why are we even building rollups? So a little bit about me. So I'm the founder of Stackr. And so the first generation of blockchains, which was Bitcoin, focused mostly on settlement in terms of asset transfer. Then came in Ethereum, which added another layer on top of it, which added arbitrary execution. However, the problem with that was the execution and the settlement was a lot coupled, was very coupled together. So they formed monoliths, and that caused all the scaling problems. So one could not scale without the other, and all of the other things like it was not that we had a lot of demands when it was invented, but now that we are getting a lot of adoption with all of these things, we definitely need to think about it. So that's where like generation 3 blockchains came in, which goes under the concept of modularism, which is separating execution from settlement. And that is where rollups come in. So the purpose of rollups is to like separate the execution from the settlement so that the application scales and like works better. So there are a few rollup misconceptions because of the initial design that we saw over here. A lot of things like got into like how a rollup should be designed, wherein it shouldn't be like that. So a rollup needs to run a VM. So it's ironic that we are at VM Day and I'm talking about like we should not run a VM, but I'll prove the point later. So another thing is like the rollups need to be stateful. So rollups don't need to be that. So you can just like take in some inputs from L1 and then just do some stuff without actually even storing any state. And the other thing is like rollup needs to be a blockchain. That's also not true. So just to go over that, let's take an example of matrix multiplication. This is a seemingly simple compute, like you just like take in a bunch of numbers, you multiply them, and then add them together. However, this gets very complex as the size of matrices grow. So what happens is like it becomes very impractical to do it on chain. So what's the solution? So let's build a matrix multiplication rollup. So there are just 3 steps. You get all the inputs from L1. You just do the matrix multiplication off chain, and you just post results back on L1. And on top of that, you can just do like easy fraud proofs because re-execution is a thing. So you can just like re-execute all the data on chain, and you'll just do like a fraud proof to check if the matrix multiplication was right or not. Obviously, it's going to cost more, but that's what fraud proofs are. So what essentially is there that you get a full rollup, which is completely valid. There is no VM because we can do the computation anyhow. There is no state because the matrix multiplication rollup doesn't store anything, and there is no blockchain involved, obviously. So what does that mean? This is a valid rollup. So that's anyone can do this. Just take input from layer 1, just multiply some numbers on a calculator, and then post it back on post back the results. So rollups essentially become like a message passing bridge, wherein you just do computation and you just post that result back on layer 1. Yeah. So these are some characteristics which every rollup should have. So they should be flexible. That means they can just there should not be any constraint on input, output, or the state data. They should be deterministic. That every action should have like a deterministic outcome, and they should publish data on L1 so that the computation is verifiable. So what the heck are micro rollups? So that's what we are building. So what the heck are those? Before that, we need to understand what the hell are general purpose rollups. So for general purpose rollups, say run a general purpose VM. The VM has all the bells and whistles that you need to build any sort of application. That VM is shared by all the application, and the apps run inside the VM. Then came in application-specific VMs. So these are modified VMs which are responsible for handling a particular set of tasks and only implements a specific feature set, but the apps still run inside the VM. What it essentially does is they kind of follow some of the characteristics, except flexibility. Because flexibility is something which these rollups cannot provide, and that's what is because you are constrained by the rules of the VM. So what's the solution? That's micro rollups. So the STF is the app logic itself. It's not that you are running a separate STF for running the application. You just implement the STF as the application logic itself. There are no constraints. They are fully modular because you can do whatever you want, and they're extremely lightweight so that you could run it on your mobile device or your browser window or whatever. So that's, yeah. So to define micro rollups, they are like standalone neo execution environment. So I just love inventing terms. So new execution environments is a term which just came up after micro rollups. And what they do is basically they do local execution, and then they outsource verification to some other entity. So the application, instead of running inside a VM, the application becomes your VM or not a VM. So this is a basic micro rollup architecture. So the user, so the micro rollup splits it into two parts, which is the executor and the auditor. So the executor is responsible for just running the application logic. The user directly interacts with the application. It sends in requests and gets a response, which is immediate, because this is very similar to how Web 2 applications work. And then the executor takes up all the computation results and sends it to the auditor, along with how the results should be verified. So it takes in the results and a verification mechanism, sends it to the auditor. The auditor generates proof or attestation, so it can actually re-execute the data or just run it inside like a VM or like a RISC-0 VM or like whatever that, and it just posts that data on L1. So that's how a micro rollup looks like. Yeah. So if you remember this, then this is what micro rollups enable. So they can just run any kind of application, send it to the auditor, and then post it on L1. And this unlocks a new paradigm for different kinds of applications. You can build games, cloud services, social networks, supply chains, identity limits. So there is absolutely no limit. So the idea is like you can just progressively decentralize Web 2 applications and make them like decentralized. And that's where Stackr comes in, which is a framework, a toolkit, and a network all built into one. So it provides a framework to implement micro rollups. It provides all the necessary tooling to build micro rollups, and it provides a network of auditors that allows you to post data and sends it across. And this is how the Stackr framework is structured. So you have two layers. One is the execution layer, which has all the applications that run all the execution in their own runtime. Then we have the Vulkan layer, which is aptly named. So it does all the auditing and the verification. It also does proof generation, and it also helps in interoperability between the applications. So the term micro rollup was actually inspired by microservices. So each application can be thought of as a simple microservice, which kind of works together with other microservices or micro rollups to become like a larger application. And these are some of the features. So the application executes stuff in their own runtime. You can build custom state machines as your own app logic. They're completely lightweight. You can have plugins. So we don't enforce anything. You can have your own sequencing layer. You can have your own data availability layer. You can do whatever you want in the entire stack. And the most important thing is it helps in sufficient decentralization. So executors can actually be deployed as like centralized application, and this helps them to progressively decentralize their stacks. So the objective of Stackr is that while it can be used to build full rollups, it does not place the same emphasis on the highest level of security guarantees or permissionlessness. Instead, it enables halfway house level of security, which was also noted by Vitalik in his blog post. So that so that it helps like onboard a lot of Web 2 application into the Web 3 space. And yeah, we are excited to learn more about like different kind of use cases. So please hit us up. The developer preview of the SDK and white paper is coming soon, and you can use this email to reach out to us. Yep. Thank you.
Thank you. Okay, do we have any questions?
This is pretty awesome. Yeah,
Thanks.
So you mentioned that it doesn't, so micro rollups don't put an emphasis on the security aspect of things, right? So the first question is, what particular use cases do you see being for micro rollups? But also wanted to get your take a bit more on the differences in utility between a micro rollup and perhaps the quote unquote L3s.
Yep. So like I said, like it's not that we don't put any emphasis on security. It's just that we post some emphasis on security. Like it's the case that it does not inherit the full security from L1, that you are running all the fraud-proof mechanism on L1. The verifier committee, which I mentioned, I think. Okay, stopped. Okay, but yeah, the Vulkan layer which I showed up is the one which is responsible for verification, and it is the one which recomputes or like generates proof, and that's responsible for creating a sovereign system. So that's what I meant by security. And for the use cases, you can technically build like any kind of use case. So let's say, for example, you're building a game, and the game requires like a very high tick rate. So you can build the execution environment, which is very high throughput environment, and then once that session is over, you can actually demarcate the entire session into chunks of time, and you can just post like a 2-second data or like a 5-second data stream of stuff on chain. So that's how that's one of the use case that you can actually build.
So the plugins thing looked really cool, but this means that if I'm building the plugin, I also have to build a verifier for it, right?
Sorry, what?
If I build the plugin, I also have to build a verifier for it. Otherwise, it's like untrusted execution, right?
Yeah, so the plugins are actually like wrappers on top of the base environment. So the base environment itself is something which the verifiers can prove. So we are building a whole execution pipeline. So it takes your code, it divides it into like executable packets, and then just run it through like a prover. And that's something which we are already building. So anything that is built on top of it is automatically like verifiable. So that's what we are doing.
So we have a VM.
Not at the execution side. Yeah.
So the auditors are actually doing quite a lot of work, I guess, in order to generate these proofs. So how is the fee market is going to look like for these auditors?
Yeah, so that's an interesting one, because when we are thinking about it, since it's a hybrid sort of system, so it has components of Web 2 and Web 3 both. So we kind of divide the network into two parts. So the user and the application becomes one economy on their own, and the application and the auditor becomes an economy on their own. So the user and the application lies in the Web 2 sort of economy, and the application and the verifier comes in the Web 3 sort of economy. That's where the fee market is there. So the committee, it's something which we're still like researching on what's the best optimal fee economy would look like. But yeah, that there would be some sort of like a fee market, or like a some sort of like a fee market. Yeah.
Okay, any other questions? Okay, if you can't tell, we're killing a little time because their speaker is on their way. Okay. All right. Do you have a question, Mitchell? Okay. Cool. Thank you very much.
Yeah, thank you so much.
Thank you. Just give us 1 minute. We're locating a speaker. Flights, right? So delayed.
So it's going to be a race between Rushi and Dimitri. Who's going to be here first to do the next presentation? I guess they were both stuck in traffic, as we all know by now. Let's give them a big round of applause when they run in. It's Rushi. Welcome, welcome, welcome.
No, I'm good. So what happened is they booked me for 3 back-to-back panels. The first available one got pushed back, and Celestial one got pushed back. So I'm everyone's problem now. Yeah, that's all I need. All right. I'm here to talk about next-gen virtual machines. So last year we saw $3 billion lost in smart contract hacks. That number is up to $4.2 billion. The problem in execution machines and next-gen blockchains is pretty clear. You probably want to deploy your smart contracts, deploy your curve on Aave, Uniswap, whatever, but it's getting hacked every year. The most common bug in today's blockchain ecosystem is re-entry. You deploy a smart contract, thinking it's all good, there's integer overflow, and bam, the next day you lose millions of dollars, if not billions, right? Move is built by Facebook. For those who aren't familiar, poured $1 billion of research, developed an Aptos and Sui, built-in bytecode verifiers, interpreters, whatnot, to make sure that when you do deploy smart contracts, it's done so in a secure and fashionable way. There's also some comparisons between Solidity, Rust, and Move. If you guys are developers, this is probably the most commonly known languages, but Move is built to have security at the forefront. So when you execute a smart contract, it actually has formal verification built into the VM itself. Formal verification is typically a principle that's built into auditing firms, right? So when you pay an auditor $100K a year to audit your smart contracts, they check for, hey, does this code have integer overflows? Does it have byte mishaps? What Move is actually really special for is it happens in the VM itself. So there's embedded verifiers, provers. So when you execute a smart contract, it says, hey, is there integer overflow? Is there like a flash loan attack that could possibly happen? All these embedded protections so that when it does finally execute, it's fully clear. It's around 90% of bugs that are fully covered with Move provers. So a little bit about what we're doing and where we are. Near just announced a DA, so that's kind of where it's come from, NearCon. But we essentially have all these different DA layers that's kind of building up into here. And this is kind of a tech stack. So right now, we're seeing a huge rush in execution layers where anyone can use whatever VM they want. We saw Eclipse launch with the Solana VM. We saw the Fluent guys launch it with the Wasm VM. And now we're coming to market with the Move VM, built by Aptos and Sui, obviously. But now we're bringing it to Ethereum in an Ethereum native way. So first off, on the M1, which is a decentralized sequencer, biggest problems we see at the Arbitrum base right now is with a single node, there's large points of failure. Now with M1, you can use 100+ nodes, have decentralized sequencing that's actually economically incentivized. So you can stake your native token, you can launch your own native token, stake it as well, and spin up your own rollup using the shared sequencer, using Ethereum settlement, using whatever DA choice you want. In this diagram is near DA. We're announcing Celestia, Eigen, and Avail partnerships later this month, which is why I'm all over the place. And use whatever VM you want. So we're fully Aptos compatible, Sui compatible, and the actual benefit is that we're fully EVM compatible. So obviously the issue with next-gen chains is cool. You have this cool virtual machine that requires a programming language, but everyone writes Solidity, everyone writes EVM code. So the question is, how can you get Curve, Uniswap, Aave, these big blue chip protocols, as well as the average Solidity developer count to use next-gen VMs? What we did is we built a transpiler. So anytime you launch a Solidity code, it transpiles out a Move bytecode and launches on the virtual machine itself. I think the biggest issue that we see in execution layer environments is everyone's like, cool, the EVM sucks, but no one wants to do anything about it because it develops like the entire mindshare, and the whole roadblock is everyone writes Solidity. So how can we scale Solidity while leveraging Ethereum settlement? And that's the kind of architecture we're bringing. The module Move VM that's fully EVM compatible, that uses the Ethereum settlement, that uses whatever DA you want. The cheapest and most efficient rollup on the market today. A little bit about more performance and more benefits of Move. For you gaming nerds out there, Move is built with gaming in mind with a concept of dynamic NFTs. Right now, if you look at a first-person shooter, you've minted 1 million NFTs when you're killing 1,000 zombies. With some mag upgrades, you're changing the caliber. That's a lot of different state changes that lead to new minting NFTs, which can often clog up the network. If you look at DeFi Kingdom and Harmony, they actually broke the Harmony chain because they're doing so many transactions. So next time this bull cycle comes, which hopefully soon, these gaming protocols that have raised so much capital are going to be minting millions of NFTs. With dynamic NFTs, with the Move VM, you can actually swap out traits as well. So if you kill 1,000 zombies, if you kill 2,000 zombies, you can swap the mag within the smart contract itself, so you don't have any of these gas issues that you see with gaming contracts. Second thing, it's designed to be modular, where it's on Ethereum settlement, Avalanche settlement, BNB settlement. You can bring the Move VM to every system with modularity in mind. And last thing is parallel processing. It's pretty much a Solana thesis in speed, speed, speed. Eclipse brought it to market in a modular native fashion. We're going to be the same thing. We notch 146,000 TPS, bringing parallel processing, specifically the DMBFT, to the Ethereum settlement and modular thesis. A little bit of Fractal, which is the EVM compatibility. That's kind of where our niche is. So the biggest issue I touched on with next-gen VMs and execution environments is how do we get Solidity developers using this? So the transpiler is pretty cool because we built a mapping system. So essentially Solidity has 146 opcodes, Move has 54 opcodes, which is why it's generally more secure. When you deploy these Solidity smart contracts, it breaks it down to the 146 ops codes, takes it to YOL, which is more of an intermediate language, and maps it to the Move opcodes. I won't get too technical, but long story short, you can communicate your existing Solidity smart contracts with the Move provers and launch on which machine. So you can actually use Move as a feature, not a requirement, which is how we actually see the adoption of these next-gen virtual machines. Solana just unveiled the Solang, which is the Solidity module. This is very similar, except it kind of prioritizes it, and it's done at the SDK level itself. The benefits here is you have full EVM compatibility. So if you're a current game written Solidity or EVM, you can now parallel process. You have 146,000 TPS built in, and you actually have built-in formal verification. So all the struggles that you've seen with Solidity, we all saw the curve attack and how bad that was. We saw the DAO attack. We saw pretty much every attack that's crippled DeFi in today's economy. Now can be prevented with a 90% success rate and actually increasing to near complete success rate with these built-in provers. A little bit about where we're at. Right now, we're compatible with every single DA solution, including the new Near DA that was launched. We'll be compatible with Veil, EigenDA, Celestia, the bigger names in the industry, as well as our mainnet solution will be a fully compatible ETH-L2 that leverages Celestia for DA and has Move VM as well as alternative VMs for solutions. The network itself is where we have our mainnet, as well as we have a few great clients, both in DeFi and gaming, launching their custom app rollups, all connected to the shared sequencing network. The problem with traditional RAS models and launching rollups is, sure, you have 900 different rollups, but there's no way to connect them all. By having a unified shared sequencing network, A, you can now make sure that you have one network that doesn't have downtime issues, but B, you can easily move liquidity from point A to point B, kind of create a unified experience. And second thing is making sure we're community first. We've all seen those tokenomics of those L1s I won't name. We're actually going to be community first, making sure that majority supply goes to the community, whether it's developer incentives, making sure the validators are getting proper yields, making sure that we're transparent in everything we do. And yeah, it's a little bit of the Move stack, which is how you can leverage the execution environment. It's the first execution layer environment focused stack where you can use whatever DA, use whatever rollup stack, but we're actually focusing more on the VM itself. We do this through a revenue sharing model, which I'll get more into a later point, probably in the panel. But essentially, you can use your VM, use whatever stack you want, and launch your Move rollup at will with composability built in. And yeah, I'll get more into the day zero partners because I know my time is wrapping up, and then we can get into the partners. What we've seen is actually a lot of organic growth, both on the EVM side. We've onboarded some of the bigger NFT marketplaces, DeFi protocols, launching natively on the ecosystem. We have a lot of Cosmos protocols building on top of us, like Shogun Finance and the latest Finance Accelerator, as well as onboarding the top 5 Aptos and Sui protocols, and kind of being a hub of all these different chains. So you have Move development, you have EVM development, and now you have Cosmos development, since we're fully IBC compatible. Kind of be a melting pot of all 3 ecosystems. And yeah, I think that's my time. Thank you guys so much, and sorry for being late.
Okay, thank
Questions?
you. What an entrance. Very New York, right?
Yeah. It's the East Village of me talking.
Yeah. Do we have any questions? Questions? I guess it was pretty self-explanatory. All right. Thank you so much. We'll see you on the panel.
You gonna go, boss? Yeah. That's for your presentation. Then another round of applause, please, for Dino and Dimitri from Fluent.
So we're going to introduce Fluent. We're introducing Fluent. Fluent is a general purpose execution layer for Ethereum. Our kind of broader idea behind this is that there are, 25,000 or so developers in Web3 today. There's like 25 million developers in the world. And we believe that you should go to where they are. Don't make them have to learn all these blockchain specific details. And we're building a product to try to bridge that gap.
Okay, so what is Fluent itself from the technology point of view? The Fluent is, as Dean had just mentioned, is a general purpose execution platform for WebAssembly languages. And the key feature of this that it's designed itself on being executed on the WebAssembly itself. So all this is possible because we have our framework. We call it a Fluent base. So what is Fluent base itself? What's the idea of the Fluent base? So Fluent base is a framework like that where you can upload your WebAssembly binary, and it is used to embed different extensions, shortcuts, and you can produce proof for this. So it automatically embeds things like our virtual machine inside, also all corresponding circuits that are required for the proof creation for all virtual machine transitions. Also, it has SDKs for creating apps using different so-called adapters for different languages, for different even high-level SDKs. Also, it has circuit extensions that are required to use to optimize some sort of VM computations, for example, for running keycheck functions or Poseidon functions, and etc. And also, it brings a set of ahead-of-time compilers that brings support of WebAssembly and the EVM support. Of course, all this possible because we have our own virtual machine inside that it runs using WebAssembly, but actually it doesn't run WebAssembly directly inside. What are the key problems of the WebAssembly itself? I'd say it's not even the problem of the WebAssembly. It's more like a problem of all existing CPU-designed architectures, because everything we have today, right now, it's designed for CPU computations that are full of binary operations, and it's not friendly with any type of curve operations. So the key problem of the WebAssembly here that limits execution a bit is that it has a bit overcomplicated binary structure that is full of relative offsets inside, and sometimes it's quite hard to prove things like doing call operations, doing operations like break between different positions in your bytecode. And for example, if you have a very, very big WebAssembly binary and you need to execute only one small part of this, you need to upload your WebAssembly binary entirely and create proof for the hash verification to parse all sections inside that is full of variable elements, and it's quite hard to prove. It requires to have a lot of gates inside. So what we do is we bring RWASM. We call it RWASM right now. It means that the reduced WebAssembly. So the idea of RWASM is it's 100% compatible with original WebAssembly form standards. So it doesn't mean that this follows binary structure of WebAssembly, but if you take any of existing WebAssembly binaries, you can translate to RWASM without losing any type of compatibility. So 100% of all features from WebAssembly are supported. Also, we run official WebAssembly specification tests, and it shows 100% coverage of all WebAssembly functionality. So what is RWASM? RWASM is a reduced WebAssembly that brings a reduced instruction set of the WebAssembly. So to simplify, it's just intermediate representation. But its intermediate representation has a binary structure that is also optimized for the Poseidon hashing, for doing multiplications on the curve operations. So and also it, of course, doesn't have any sections inside. So we entirely remove all sections, and we honestly remove entire WebAssembly structure by keeping full backward compatibility with the original structure of, with original features of the WebAssembly. So, and the thing that we embed RWASM inside the Fluent base framework, and Fluent base runs RWASM. Also, we embed our framework, execution runtime inside execution runtime itself. So if you run some execution flow, you can run like some sort of controls. You can run some different types of applications. And we also support, as I mentioned before, ahead-of-time compilers that can be used to translate your original binary from EVM structure, from WebAssembly structure, to our special reduced structure. And you can run this and prove without any additional computation overhead. So the only thing that is required, honestly, this is the key goal of the Fluent, that it has internal tree structure, and it stores information about your execution binary, and you can upload any type of binaries, and it automatically translates to the optimized version, and it can run without any additional overhead. And if you want to call the contract, to call your application, to interact with your application somehow, no matter what size of this application, how complicated the structure is, there is no need to upload your WebAssembly binary and parse it and verify entirely, because our intermediate language is designed to have more like so you can easily upload the binary and run as is without any additional validations, verifications, and etc. So this is the idea of the Fluent that has Fluent base inside and have RWASM inside. And also one thing that we optimize for the RWASM that is also very important is how you interact with external modules and external functions. Because if you want, for example, embed some circuit accelerated extension inside your binary, you need to put special item into your section. You need to parse. It has UTF-8 encoding inside. That is quite a bit hard to prove using ZK. And also you need to prove all relative offsets inside. That is a bit overcomplicated. So we also optimize this, and we reduce all these computations to only one instruction and only one lookup element. So you can easily look up the existence of this special optimized circuit for your function. And for the regular developer, it looks like a developer just invokes some function that he or she imports into the model. And we're going to provide a set of optimized circuits. We call it like extensions or external circuits, and you can embed different circuits. So what's an example of such circuits? We can bring support of things like, honestly, we already have partial support of VASI execution environment, so you can compile your glibc applications. Also, we have support of ZK trees. We have support of Merkle-Patrizia trees. Also, we have embedded RWASM itself, so RWASM can prove its instruction itself inside without any additional overhead or additional computation costs. And also, we're going to bring all extensions for the creation of the Ethereum apps. So like everything that refers to RLP encoding, you can do using only one function, and it automatically replace all your computations with our circuits. Yeah.
So how much time do we have? Are we over? Q&A? If there's any questions, we'll take them. If not, I'll probably ask Kim some questions to clarify some things.
Okay.
Yeah, how does this compare to Polkadot's WASM or other implementations of WASM on blockchains?
Like what specific implementation of Polkadot WASM? Do you mean WASM interpreter or what specifically?
I don't know that much about WASM, but the WASM that's used to write Polkadot smart contracts.
So yes, WebAssembly is just a standard, and we here strictly follows WebAssembly standards. It feels like that Fluent base is something like a substrate for the Polkadot, but we don't support Polkadot structures. We don't support Polkadot host SDKs, but the key feature of the Fluent that we can embed Polkadot native functions inside Fluent base. And if someone wants to run ZK optimized circuits using Fluent base, we can just develop a special set of extensions and SDKs for the Polkadot, and we can bring almost native support of the circuits into the Polkadot, into the Fluent base to bring support of the ink contracts, for example, or even running the substrate. So using Fluent base, you can build ZK substrate, for example.
And just to add on that, like the way we think about what we're building in comparison to kind of some of the other WASM approaches in the space and history is, I mean, we kind of separate it and say like, okay, there's like the consensus part of things and social layer part of things, and then there's like the execution part of things. And we think that like execution was always like a good idea. And I think what's really the best way to implement it is in kind of like a permissionless sense and a layered architecture on top of like a consensus layer and a social layer that's already gained like escape velocity. And yeah, that's kind of how we think about it. Any other questions or any more time?
We can do one more question.
Do you have an estimate of how much your like WASM binary sizes increase when you translate to RWASM?
Actually, it increases because we align all instructions with the field elements. Right now, we consume around 9 bytes per one instruction, and the size of this is always fixed. It is required to simplify the circuit for the Poseidon hash verification, so we don't have to spend additional columns in case for the verification of the field input for the Poseidon hash. And so it increases right now, but at the same time, we did several measurements. For example, one transition cost for the EVM cost around 1.2 million instructions. In our implementation with the optimized translation, we have only 0.5K instructions. So it can bring up to 2 times, up to 2 or 3 times optimizations. Of course, it's not like, it's only about a number of instructions because under the hood we run our circuits. And so like it's something, it feels like a programmable scroll, or for example, programmable ZK-VM. If you take the code base of the PSE of the scroll and you modify this, you also need to modify circuits. So here you can prove all transitions from one circuit to another circuit using WebAssembly language. And you can use any of existing languages like Golang, Rust, and etc.
Thank you, guys. Dino and Dimitri, give them a round of applause, please. Yeah, you can give it to Max. Then we're going to move on with the first panel talk about adoption challenges and opportunities. I would like to invite Anna Rose on stage first. This is going to be our moderator. Have a seat, either this side or that side. I'll grab you a microphone. And then I would like to invite all the speakers back on stage to join Anna for this talk.
Does someone want to sit next to you? Actually, I can sit over here. I'll come.
There's going to be another one. There you go.
Great.
Yeah, I did.
Yeah, it's going to take some minutes. So pour yourself a drink. We'll start in 2 minutes.
Just so I know your names. Rami? Is it okay? Is it okay? And are you Russian?
That's very good.
Yeah. Oh, can I just ask you, what's your name?
Rushi.
Rushi. Do you know?
Kautuk.
But this one's going to be hard.
It's Kautuk.
It's working. I'll give you another one just to be sure. Hello? Yes. Just check.
It's true, we're a little bit early, aren't we? We're 2 minutes early. I sort of might, maybe I'll ask you quickly about this question because I think it's the one topic.
No, we're just trying to get it. Yeah.
Just so I don't ask
You good? Go. All right, you can take the left side as well if you want. That's all good. All right, give us a short introduction and then the floor is yours.
All right. Hey, everybody. My name is Anna. I'm the host of a podcast called Zero Knowledge. I'm also the co-founder of a company called ZK Validator and the co-creator of an educational portal called ZK Hack. And we just did a hackathon that ended yesterday. So my voice is actually, I'm just realizing as I speak to the mic, suffering a little bit. So I'm here with 4 guests from 4 different projects. I know 3 of you just did lightning talks, but I think it would be worth it to do a quick intro to each of you and your project. Why don't we start with you, Rami?
Hi, my name is Rami. I'm an engineer at RISC 0. I've recently been working on Zeth.
I'm Rushi. You saw my super lightning talk. I'm from Movement Labs, bringing the Move VM to the modular stack.
Dino, co-founder of Fluent, and we are building the ZK WASM execution layer for Ethereum.
I'm Kautuk. I'm the founder of Stackr Labs, and we're building micro rollups to scale Web 2 and Web 3 applications.
And yeah, so I mean, I think starting out, one of the questions that I have definitely is about like EVM, and like here we're talking primarily about VMs, and I know I just saw your lightning talk where there's a transpiling to EVM, but why didn't you decide to just build the EVMs like a lot of these other teams are doing? Like what drove you not to do that?
The EVM is broken. Every year there's $4 billion lost to smart contract hacks. If you have asked any Solidity developer, hey, do you like coding Solidity? 99% of the chance, unless they're clinically insane or worked at consensus, something like that, the answer is no, right? Security is at the forefront of our thought process. And every year there's so many hacks. You go on Twitter, you'll see like, oh, it's $40 million hack, oh, it's $60 million hack, but no one actually is like, how can we change this? And that's kind of the thesis behind like DM project. They were gonna use this new programming language to power Facebook's decentralized network in their stablecoin. Obviously, SEC struck down, but now that thought process comes back to our stack. How can we take this Facebook's billion-dollar programming language, bring it to the execution layer, and then bring it to Ethereum? So that's kind of how we looked at it.
And what about you, Dino?
So most of my background before the last 3 years where I got deep into crypto was in kind of like Web 2 developer tooling and infrastructure. And if there's one thing that's become very clear over the past, I guess this the mobile cloud boom is that, and the kind of the general microservices architecture that people use to build apps today is that like developers want to pick the best tool for the job. And so we just at the core don't, believe in trying to make developers kind of learn all of these blockchain specific things. And we think kind of opening up to new languages is kind of the first step towards kind of unlocking like better developer experiences. And I think that there's a plenty way to go after that in terms of like abstracting things away from developers. But we just think that's like just crucially important if we want millions of devs.
I was just thinking though, like the EVM also does have a lot of tooling for these developers. In the case of Move, it's a younger language. Does it have the same kind of tooling, or does it not need the same kind of tooling?
So that's kind of why we designed the compiler, right? So like the truffles, the hard hats, that's all fully compatible with the underlying VM because the SDK itself transpiles the bytecode, right? So you get all the benefits of like EVM tooling, EVM community, you can get Curve Aave deployed seamlessly, but the underlying VM has the provers, which makes it secure, and you have parallel processing. So yeah, all the tools are there, and we're building out a lot of additional tooling as well.
Okay, and what about for ZK WASM? Do you get to make use of the WASM tooling?
Yeah, pretty much. So it's less of a less friction to get started, kind of building that type of ecosystem, just because we don't have to start from scratch. And we honestly, obviously, there are a bunch of different approaches to kind of like the alt VM solutions, and we just find WASM to be like a really excellent kind of sweet spot on that trade-off space because it does provide so much flexibility, but at the same time, there's also a lot of kind of like I'll say like brand recognition of it. It's very popular already. People know WASM and it comes with tooling.
Does your system also have any connection to EVM?
Yes. So we do support Solidity and kind of like all EVM tooling, basically.
Kautuk, I want to ask you a question. I missed your lightning talk, so I didn't actually hear like what language or kind of toolkit would people be using with your system?
Right. Yep. So I basically talked about like building microservices for the Web3 world. And these microservices could be like the micro rollups that we are building could be implemented in any sort of language. So the idea behind that is you build your application in, and that executes in their own runtime. So that allows you to build any sort of application in any sort of runtime. And that then there's a layer in between, which is the auditor layer, which sends it to L1. So the executor layer is completely agnostic of whatever tooling that you need to do. And it's completely like different from like the other VM sort of paradigms.
And yours, does it then kind of like, does it become a rollup on Ethereum, or is it a rollup for any network, any kind of base chain?
Yep. So we can decouple the settlement and the DA, and it can actually get on top of any L1. So the settlement can happen on Ethereum while the DA comes on another the data availability layers of some sort. So yes, so technically it can run on any chain.
Great. So I think I'm most familiar with the RISC-0 project, but why don't you weigh in here? So I know it's Rust based. You decided not to do EVM. Why?
Well, well, because we have the prover for the RISC-V bytecode. So that was mainly it. But in the end, we also ran EVM. We emulated the EVM inside of our system. So we're kind of a jack of all trades in this sense. We can be a rollup that is just an application that sits on Ethereum. You can also enshrine Ethereum inside of the RISC-V zkVM.
Is that the Zeth? That's an EVM rollup? I know I spoke to your founders about this, but
Yes.
I forget how does it connect to RISC-V?
So we run the EVM inside of our prover. So we basically compile down the revm crate into the RISC-V bytecode, and then we run that as an executable in our zkVM.
Okay. And what's the name of it? This is Zeth, right?
Zeth.
Yeah.
That is Zeth.
I actually was curious about when you talked about this transpiling down, if there's any kind of like loss of performance. Like this is, okay, so I'm not a developer, so I might not fully get this, but like, do you just do that once when you're like deploying the contract and then you never have to do that again? Or do you end up doing that often and it could actually like affect performance?
Yeah, so you deploy the contract once, but every time you invoke a function, let's say like you're deploying curve deploys once, but every time a user calls a function, it just calls opcode, like mapping it.
Yeah.
It's like 146 facility opcodes, it's 54 move opcodes. That's a one-time deployment, but the functions are called repeatedly.
But does that affect performance then? Like the fact that you're doing this kind of transpiling?
Not so far. Our TPS is like for the EVM, it's around 60K, and obviously in theory, and the move VM is 146K. So you lose like around half, I would say, but still it's like 60K theoretical, still pretty good, I would say.
Okay.
So you can either choose the right move, which we'd encourage you to. The slowly side is more to like, hey, like if you don't want to, there's also some functionality.
Okay. And actually in the RISC-0 case, is there any loss of performance in something like Zeth?
Well,
like using EVM
yes.
in this context? Because yeah. Oh, in this case, it's not transpiling though. It's just full EVM. It's a fork.
It is essentially just running the EVM inside the prover.
Yeah, okay.
And that does come with a bit of an overhead, especially because we haven't really optimized that revm crate to run inside our zkVM. And in the end, you have the overhead of emulating the EVM inside of a zkVM instead of directly specifying a circuit or a proving system directly for the EVM bytecode. So there is a bit of an overhead, but it's not like a 10x overhead. It's more like 2x or.
The overhead would be like proving costs in this situation, right? Like
Yeah.
to run this provers. Is there any like estimates for like how like just compared to normal EVM running compared to like when you have a prover that's running the zk EVM, how much more expensive is it? Do you know?
It is hard to get those kinds of metrics because it's not apples to apples. But for example, to prove an entire Ethereum block, I believe it was $20-ish. And it's more of a cost effectiveness trade-off, because if you do want faster proving time, it's all fully parallelizable. You can just add in more GPUs, and then you can go down from 50 minutes to 14 or even less. So.
I want to go back to Kautuk about these sort of mini rollups. I asked you if it had to be on Ethereum. You were like, actually, the DA can be somewhere else. But is your project sort of in the same category as like those like roll kit? Is it meant for like a developer would approach it not to build upon a rollup, but rather to deploy their own always?
Yes, exactly. So if you really want to compare, so I think a good comparison would be roll kit. Sovereign Labs, OP-Stack. So it's a different rollup framework. It doesn't allow you to spin like the same framework. It's a framework on its own. So yeah.
What's different about it compared to those?
Yeah. So as I mentioned, so it allows you to like it separates the execution and the verification. So you just build your application as a regular Web 2 application. So like similar to how you build like backends, just build your application like that, and it just collects all the data. So we're building an execution pipeline which takes your logic. So you build your application and you build the state machine. The application logic as a state machine on its own, so that a state machine is specific to your application, while the others give you like a VM, which is the state machine, and then you deploy that application on that VM. So instead of us, so you build your own state machine in our case.
Interesting.
Sorry, how does the verification work?
Yeah, so we have like two modes of it. So one of them is the audit process, which is simple re-execution. The other is like converting the binaries into like a WASM compile, and then from WASM to like running it inside like a ZK VM. So that's like the other mode. So you can just take the application logic, you take the state machine, we have like a fixed abstract method for it. You just need to comply with that, and then it converts the execution pipeline, converts it into like a WASM bytecode, and that runs inside a ZK VM. So yeah, we are actually trying out like different methods.
Rushi, I was wondering kind of about, because you're working with the Move language, which, and I don't know if you mentioned this, but it originally comes from the team that is now SWE, and I think Aptos. Do you have any connection to them? Or is this like you're just using you're just focused on the Move language?
Yeah, so I built the first DEX in Aptos. My
Okay.
co-founder built the first yield diagram at Aptos, and it's like August of last year. So we were two of the first builders in the space.
Okay.
And we're like, this language is cool. I want to use it. And then FTX happened. We're like, damn, that's sad. And then we're like, okay, let's just do something else.
Cool. I wanna talk about use cases for each of these systems. And I'm curious. I'm sure, given that you're so deep with your system, you'll have sort of like the ideal use case. But I'm curious if any of them are the same. So I don't know. Maybe we start with you. Like when and I know RISC-V is like quite general purpose, but are there any? I don't know. Are there any use cases that you would say like you should definitely be using your system?
Well, it depends on how you want to compose your system, I would say, because you have a lot of flexibility, whether you want to be a rollup or you want to ZKify some pre-existing system. So it's hard to say without knowing what the objective is.
Would you say maybe also here in this case, like the use case is actually like a rollup builder, kind of like it's like a type of rollup deployment that or like some, yeah, like I know you guys have also touched on the coprocessor side of things. So
yeah,
okay.
So if you do have one application you'd like running on an L1, you can use this coprocessor model to offload the execution to that ZK coprocessor and then have provable results returned to your blockchain. So that is also another way you could do it.
Okay. What about you? Do you have like a dream use case?
I mean, I think every infrastructure project is trying to find use cases. I think you'll get the normal answer of like DeFi, gaming, NFTs, which everyone is trying to do.
Yeah.
So I think if you want to go uniquely, I think you look at the developers, right? And I think we're focused more on security-focused developers. People who are like, I want to build security-focused apps. I want to build like on top of parallelized runtime. I think those are two main avenues: DeFi for security for obvious reasons, and then on the gaming side, or any consumer app, having high throughput is important. But I'm sure every infra builder says that.
Yeah, so let me actually separate Fluent Network and kind of like the general purpose smart contract environment that we're going to market with from kind of like the broader framework, which Dimitri might have talked to earlier. So as we're kind of getting this smart contract environment going, we are making some optimizations for like higher throughput use cases. And mostly this is from conversations with devs over the past half year where, you know, a lot of people who are building in like gaming, social, like consumer-y looking use cases seem to really want to use kind of like very simple Rust, TypeScript, Solidity on Ethereum. That's kind of like our initial focus. And so obviously we optimized kind of the network around that because I think the Fluent-based design will enable much more flexibility for all different types of use cases. But to go to market, yeah, we'll start off with a kind of an optimistic ZK kind of like design. So there's higher throughput there, and we'll be putting all kind of like, you know, input data on EigenDA. So we're making some of those design decisions to work better with things like on-chain gaming and stuff like that, and we're starting to get a lot of interest there. So I obviously it's a permissionless general purpose system, but like I am very excited. I'll put it this way: I'm very excited about those types of like net new use cases.
Any particular?
Yeah, so for us, we're going to the consumer apps like that exist today from the likes of Uber and like Microsoft's and all of those things. So our main objective is to progressively decentralize Web2 kind of applications. So I think it's interesting that Vitalik did a post like a couple of weeks ago, which was like a different type of L2s. So that is basically what we are going towards. So yeah, all those applications which the term he mentions halfway house of security, like applications which want to have some part of their stack decentralized while progressively going towards like full decentralization. So that's the kind of applications that we are targeting.
I'm going to actually ask a similar question, but switch it a little more towards like what kind of developers should be using it. So in your case, you mentioned it's like you can run any language, but are you maybe as a company kind of really targeting one group or like thinking about one particular language that some developers are using?
Yeah, so we are starting with like regular web developers. So that's why we are starting with JavaScript because like web application is like makes up 99% of all the applications. 1% is all of the other. Don't quote me on the numbers, just like a exaggeration. But yeah, that's what we are going towards, like web developers who are using JavaScript. Then we'll eventually go to Python and then Go, Rust, and all of those things.
So JavaScript developers are going to be deploying rollups.
Yep.
Wow.
And those rollups are going to run in their browsers.
Okay. And in your case, I guess WASM, but like what kind of developer are in that community? And maybe actually you should answer which languages.
So obviously the goal is, I mean, we support any kind of language that compiles down to WASM, but like our initial focus, which I think is kind of your question, is around kind of Solidity, Rust, and TypeScript, which you can all kind of blend together nicely. And I think developers who want to do that on Ethereum, whether we're seeing developers who just want to, it could be very simple. It's like, I want to program in Rust on Ethereum, just easy way to put my dApps in Rust on Ethereum, to people who are building kind of like more, some of the autonomous worlds use cases where they're like, hey, I want to put kind of like the core logic of this thing in Solidity, throw some financial mechanics in there, and then make it permissionless to anybody to like extend that game or that world in some other language. Like these are the types of, I guess, developers that we're starting to kind of appeal to. And yeah, I mean, maybe that's a little bit of a different answer from before, hopefully.
Yeah. In your case, I guess it's Move and Solidity.
It is Solidity compatibility, but I think the bet is really on like similar to like Solana Eclipse thesis, right? You have this big L1 with naturally big funding and like a big ecosystem around it, and thesis, okay, if Solana developers kicking up, they're going to want to bring it to Ethereum. The same thing as us, right? Both Aptos and City raised $300+ million. The combined market cap is ridiculous. So the bet's over the next few years, if more people already move, which they are, specifically in Southeast Asia and Korea, we're going to provide a way for them to bring it to Ethereum. I actually have a question for you guys, because we're probably more in the Rust playbook, while you guys are WASM. I'm a Cosmos WASM dev, and I know the hype was in Polkadot and Cosmos back in the day. How do you guys get over like the WASM derogatory, if you will, where it's like WASM is dead, but in reality, WASM is just a backend. But if you're going to be marketing WASM compatibility, how do you guys like navigate that?
It's a good question. I honestly, at this point, we have focused mostly on people who are excited about WASM, and there's no shortage of them. And so as much as there could be for people who have been in the space for a long time, and yeah, maybe there's not a bad taste in their mouth, but they could have seen like, oh, well, WASM was tried here and there and there, and you know, why are you guys picking that? I think for every one of those, there's a greater number of people who are actually just excited about what WASM kind of offers. So, I mean, how do we, that's the best kind of answer I got right now, just kind of focusing on the people who are excited about it.
And in the case of RISC Zero?
Yeah, I definitely see, I see hybrid approaches working quite well, because we're not really a network. You know, some pieces we actually don't target at all, like data availability or interconnectivity between things. So I definitely see developers using possibly the ZKVM in some parts and another platform or another language as a top or bottom layer for that, depending on their needs.
Also, I just thinking back, like in terms of use cases, didn't you guys also make, there was like an ML use case, sort of this running machine learning like allowing for so much computation to be happening in these other environments. Is that still a use case for you?
That still would be a use case. It is a type of computation that you can basically offload or perform privately and then provably show your results for.
Cool.
So hybrid approaches all the way.
I have a question here about onboarding new developers. So I think we've talked here a little bit about who you're trying to reach out to, but yeah, how do you get them to use your system? And actually, I don't know, are any of you, like, is your project at the point where you're like actually actively trying to get them to use it, or is it still in development? So maybe say first, yeah, the status of the project and then what you're doing.
Yeah, so we are actually like releasing a developer preview about next month. And for adoption, I think it's interesting to it because we can ride on like another JavaScript framework for doing X. So that's what we might be able to go forward, that, hey, there's a new JavaScript framework which allows you to build rollups, which is like definitely an unseen thing. So yeah.
So we, our private testnet, I'll say, is like right around the corner. And so, yeah, we're actively looking to speak to folks who want to build, dApps in these languages on Ethereum in the very near future. So we are taking kind of like, you can go to our website, fluentlabs.xyz, and not to just to show a little bit, I guess. But yes, we're right there, so you can sign up.
Yeah, we're on DevNet, and I think one of the benefits that we have is we can ride on the backs of two giants. So we work closely with the Aptos Foundation and the Mystic Labs Foundation, and really both of them see us as like a value add, because if you're giving more Move mindshare, get more people talking about Move, which is what I'm doing here today, it's better for the overall ecosystem. So they get to do their BD work, and we're like, you can deploy on Ethereum too. Isn't that cool? So that makes our lives pretty easy.
Yeah, we're still in the development phase, but we've also gotten to a very mature stage. So we're able to execute very complicated things like the AVM, the EVM, and we've also recently deployed Bonsai Pay on Sepolia. So we are actively looking for use cases that developers want to do, and we just want to see use cases that we possibly can make easier, can make them happen easier. But yeah, there's no network so far. So one network that we would love to get to at some point is a decentralized proving network, and we're still, that's still part of the roadmap.
One token.
No, no token.
Would you all consider yourselves like in the L2 space, or are you also sometimes thinking of going more to like the L3 space? Could you then deploy your system on another rollup?
Yeah, so for us, since we are doing like custom state machines, it doesn't really make sense to do an L3 because the value that you'll get like building on an L2, it's kind of like diminishing. Like you'll probably get like 1 or 2% more juice out of like running on an L2, running as an L3. So we would be focusing on like running in the L2 mode. However, like I mentioned, you can settle on any, like the way it is structured is that you can settle on any smart contract based chain. So definitely you can do an L3, but it's not like practically viable to do that. It's like you would get no returns.
So everything I've said so far has been focused on kind of our initial thrust, which is like the smart contract platform. But we're also, as Dimitri mentioned earlier in the lightning talk, we're building kind of a broader ZK framework that will support people building kind of like L3 like constructions. We like to call them like kind of shared apps versus like sovereign apps, because at the end of the day, they're just state machines, and you can change, you can put different things like data and proofs in different places. But like, yeah, if people kind of like align with the L2 in that kind of way, you can absolutely build L3s.
I think L3s confuse me as like, do we really need these things? Do we really not need these things? I think it's more about alignment with the particular ecosystem. We're just a VM, so you can use our VM for L3 if you so choose to. But I can't say that's a priority.
Okay.
Yeah, we're big on interoperability, so we'd be happy on any layer, to be honest. As long as you run the verifier, we're good to go. You can move your program anywhere you want.
I feel like I maybe should have also asked this earlier in the way you think about your project. I think you kind of answered this here, where it's like, do you imagine your kind of iteration of an L2 or L3 or rollup just being once or like multiple times? Because I know in your case, it's many of them. In yours, you're going to create a framework, which I guess allows others to deploy it. But in yours, is it sort of like a focus, at least at the start, on a single rollup?
Yeah,
It's
I
actually
think
to you, sorry, yeah.
we're focused on mainnet, have like a chain, build a DeFi ecosystem,
Yeah.
do all the right things to
Okay.
build out the right chain. I think the RAS space is rather competitive.
What is that?
The rollup as a service
Yeah,
space.
yeah, exactly. All the big
There's
ones.
a lot of rollup as service providers, but how many people actually want rollups is the question. I don't know. Maybe you guys can weigh in on that.
I think it's early days. Like I'm definitely in the mindset that eventually there will be, thousands and thousands, if not more, rollups, and some micro rollups, some general purpose rollups, some kind of industry focused rollups. I mean, you can get to a point where you have, I don't know, like a little machine learning model running in the browser, and that can technically be a rollup or whatever. So like I think there's going to be a ton, but I think right now it's definitely from our vantage point, it's higher impact to the space to focus on kind of a general purpose platform. That's why we're kind of starting there.
Yeah, just to add to that. So I don't see rollup as like the end goal. I see rollup as a tool. So rollup is more like a process. Like you building smart contracts, you don't call them like smart contracts, you call them apps. So eventually we'll get to a point wherein like we don't like we won't be saying like this is a rollup. We'll just call it like these are like some apps built using like maybe Movement or like Fluent or maybe Stackr or maybe RISC. So that's where we'll eventually go to, wherein like all of these things will be abstracted and these will be just apps. That's all.
Hard agree.
It's just, so it makes me think a little bit of the kind of Cosmos thesis a few years ago. They created the Cosmos SDK and it was like anyone can make their own chain. And then there was this moment where everyone made their own chain. And then a lot of those chains kind of died. It turned out there's actually just a few who can make it. Do you think rollups could go through a similar thing with like a flurry of new rollups, but actually not all of them take hold?
Yeah, I think personally, I think it was more from the standpoint of like how the validators worked with the app chains. So the best part of building apps as a rollup is that you don't really need to bootstrap any of the security.
Yeah.
So that you get free, like you just get out of the box.
You get a
have
validator set.
You have such a vast validator set which like puts in so much economic incentive to not do anything wrong, and that's where rollup like takes over like a huge win over app chain. So that's my thought, but curious to hear others.
Similar thought. My mental model around it is like to get like escape velocity and really like bring an awesome execution environment into existence. You kind of have to do the consensus and social layer first. You have to get escape velocity around that first. And I feel like there's been a lot of attempts where that layer of things, both socially, the social layer basically, just like kind of never reached that escape velocity to where the execution environment can kind of proliferate. So like I definitely think that in kind of like he was saying, it just doing it in a roll-up world makes it so much easier for devs to just kind of like get started building these things. And yeah, I think that makes like all the difference.
I think the Cosmos ecosystem, like the technology pieces were still very important today. Like sure, like all these app chain theses didn't really work out, but IBC is still an important standard. Tendermint is still an important standard, and they're used in the biggest chains today.
For sure. I didn't say Cosmos is dead. I said some of the chains.
Yeah, for sure. So I think that's what's going to happen to like this rollup stack framework. Like rollups is going to be abstracted away. Like sequencers is going to be normal parts. Like shared sequencers be normal part of tech stacks. VMs are going to be normal parts of tech stacks. No one's going to be like, this is the rollup thesis or this is the modular thesis. It just can be like used in normal everyday technology.
Yeah, rollups are a really loaded term, actually, and that term has been growing in complexity throughout the past few years. To me, it's just transaction pipelining, very generically. It's a way for you to start off-chain with some piece of information or some process, and you want to land something in some chain that just confirms what happened in your process. Yeah.
I kind of wonder, if there's all of these rollups locked into the L1, do we end up with another kind of case where like, yes, there's great computation on the L2, but like, could it clog the L1?
Yes.
Like, yeah?
Yeah, definitely.
Like
At some point, yeah,
Yeah.
you would, unless optimizations are made at the L1 to scale kind of like the data throughput there, because then eventually it just ends up being kind of like a data dumping ground.
That's what I kind of just realized. I feel like the shared sequencer people know this, the MEV people know this, but it's just sort of dawning on me that, okay.
And that's the point of the DA layers, right? Like these alt DA layers are meant to make the gas fees next to nothing. Like that's the point. Celestia has the point of EigenD, that's the point of Availa, et cetera. Use Ethereum as settlement security, but in theory, over the next few years, the gas fees for these rollups should be next to nothing, which brings the question is like, how valuable is a single, like one sequencer compared to shared sequencers?
Yeah.
Yeah, once you're on a distributed system, there are fundamental things you can't overcome, especially if you're doing a decentralized blockchain. You will, at some point, all you can do is just increase the requirements on the nodes that are participating in your network, so that you're propagating blocks faster, you're verifying things faster. At some point, you just hit that wall. There's no way around it.
I think it was about time for us to open it up to questions. Just want to, should we do questions now? Is that okay? Okay, so I don't know if you want to take a minute to think of some questions. I have one last question to ask you guys, but yeah, if you want to just think about it, maybe put up your hand and they can bring you a mic, if you have any.
Are there any questions already?
I can continue
Yeah,
asking,
sure.
but if you
Go
have
ahead.
some. So I was thinking actually, as we were talking about like these frameworks, there's the OP stack, and basically every major L2 system is kind of following suit with their own. They are sometimes offering more versatility, like being able to run different bytecode in the rollup itself, or choosing a different language or different VM. Are you competing with those in a way? Like, are you competing with, I mean, not OP stack maybe, but like the ZK, what did they call it? The ZK sync
stack?
one,
The
ZK
ZK
stack,
stack.
yeah.
I don't think we are competing. We're actually going to be using and partnering with these folks. So partnering with, like, for example, OP-Stack launched a Magic client, which allows for Rust-based VMs to launch on top of them. So they're actually partners with us. Maybe for Kautuk, it might be different.
That's interesting.
Yeah, I think, like I said, it's a different framework. It's not that we are going after their market. It's just that we are like in a different zone. So maybe they can come after us or something like that. But yeah, that's a possibility. But yeah, no further comments on that yet.
We just want to grow the pie, man. More devs.
I think what's really interesting is at the execution layer, it's very new. Like no one has really been pushing like bringing like everyone's been stuck to the EVM for years. No one's really thought of, hey, there could be other VMs to Ethereum. So I think the role framework space is pretty crowded. You have like everyone and their mom doing like role frameworks, but Kautuk's amazing, obviously. But I think the VM space is yet to be open up, where you can take different programming languages, take different VMs, and then partner with these larger role frameworks and be like, hey, we can move to Arbitrum or bring WASM to Arbitrum.
Did anyone have any questions? Did we have any hands? I can keep going. Should I just keep going? All right. I think we have a few more minutes. I actually wanted to ask, I wanted to kind of go back to the RISC Zero model and talk to you about this, like, or actually ask you about the sort of area your project or the RISC Zero and a few other projects are trying to kind of create. It's not the central chain with the rollups. These projects, I feel, kind of like float around them. They they touch them, but they don't necessarily have that same kind of hub and spoke look, at least. Can you speak a little bit more about what the vision is for that? Like, would you imagine RISC Zero working with these L2s?
Yeah,
or with these
definitely.
rollup teams?
Yeah.
Okay.
So we are.
And what would you do for them? Like, why would they work with RISC Zero?
So one thing we're doing for Optimism, for example, is we're building basically a ZK version of their fraud proofs. So it's a single shot proof rather than an interactive process. And part of what we could do is basically just take over the ZK part, and you would just be free to actually build out how developers specify their apps or what the languages are. Or it could be something that is specified as part of one of the applications hosted on your frameworks. It really depends on what is best for the developer, because for some use case like ML, for example, it could be that the best or most efficient way to do it is using the ZK ML stuff that we have, or for some other use case, it could be that something else is more efficient. A DSL, for example, could be just sufficient, could be not rigid, too rigid for the developer or so. So it's hard to say generically. It all depends on what the developer wants to do at the end. But of course, to optimize further, it gets more
Is it
complicated.
competing with Polygon's prover network, or you work Polygon?
So we both have a ZK EVM, I would say, but we're basically the first Type 1 ZK EVM because of how quickly we just put it together. Yeah.
With that OP deal, there's two projects, right? It wasn't just RISC Zero. It was
O1 Labs.
O1
as well.
Labs and RISC
Yes.
Zero. Okay. Are you guys building the same part together, or are you building two iterations of it?
So we both made different proposals for the RFP. And I'm not 100% in sync with what O1 Labs is doing, so I can't speak for them.
Got it. This is sort of moving to maybe a different part of the stack, which is like the shared sequencer models. Does that affect you guys? Are you paying attention to that? And actually, you might be a good group to just ask, like, what is your opinion of shared sequencers? Will this be a thing? I'm trying to dig into this topic right now and having I'm seeing two sides.
Yeah. So sequencing, so we kind of divide sequencing into three categories instead of just like private and not, like shared. So it's like private sequencing, within the app is in control of the sequencing. The other is like third-party sequencing, which may not be shared. It would be just like specific for one application, but still like someone else does it. And then there is shared sequencing, wherein like several apps share a sequencer. So for us, like, we don't have like a opinion on like what the application should do. It's like left to the application to do that. Ideally, we would like to see applications doing their own sequencing. Like that's what we are thinking about. Like what happens if we let applications control their own mempool and just build the best possible transaction. We eventually see like that's an optimistic assumption that people would actually lean towards like doing good for their customers, like building the best possible MEV and then getting it back to the customers. But yeah, shared sequencing is something which, or third-party sequencing, something which could be valuable. Like, hey, some application, like I keep saying, like progressively decentralizing their own application. So let's say right now, when you ride when you book a ride for Uber or something, your transaction goes directly to the Uber server and they decide on which drivers see your transaction and those kind of things. So what if in a situation, like this is not traditional sequencing in Web3 standards, like some different kind of sequencing, wherein the user like sends a request and then there is a sequencer which decides the algorithm on what drivers should see your application's request, and then they decide what matches your application. So
I never thought of the sequencer as that. But that's interesting.
Yeah, so these are kind of like novel use cases that we are thinking in terms of like getting like Web2 applications to decentralize their stack.
I think from a tech point of view, shared sequencing makes sense. But I have this running joke where I go to these shared sequencer groups and be like, how are you going to convince Arbitrum and Base to decentralize sequencer? And it's always like, regulation. I'm like, guys, that's like 4 to 5 years away in the best case scenario. How are you going to convince Base to use a shared sequencer? And I never get straight.
Also, decentralized sequencer is not the same as shared sequencer.
Yeah, there's too many issues here. In this world where DA gets cheaper, right now, Base can justify their sequencer because Ethereum costs like $7. They can charge $10. Their users won't care. In this world where DA becomes cheaper, now Ethereum transaction will be like $1, right? So now you can't charge like the 10%. The 10% extra is now 10 cents versus like a few bucks. So now like the sequencer models get like worse and worse, and there's no incentive for Base or Arbitrum to ever decentralize sequencer. In the cases I like it is when the Sila proposal, where Sila proposed to take all their, the validators for L1 and turn it into a layer 2. Now there's actually economic incentive for the sequencer to decentralize because CLO token holders have to stake the token to participate in sequencing the network. So it's actually value accrual back to the token, which makes it a sustainable business model. In the current situation, Arbitrum and Base and Optimism will never use a decentralized sequencer unless Gensler knocks on the door in the next 4 to 5 years.
Wow.
So
now we have questions.
We have questions.
Apparently, we're cutting a little into the break, so if anyone wants to take the break, maybe they're welcome to. Okay.
Hi, I'm Graciela. So I think my question is mostly for Rami. Obviously, we're all in Web3 because we care about decentralization, and you guys have mentioned decentralization a few times, but I'm wondering like what is really in the way of, you also spoke to the maturity of your product. What's in the way for Bonsai Network to actually become decentralized and permissionless? And then I guess maybe to Kautuk, like, are you guys thinking about introducing decentralization to your proof marketplace?
Well, there's not much in the way except just having to work on it. Recently, we've open sourced many more components, for example, recursion improving, and we keep changing basically and reshaping how many parts of our system work. So I would just say it's not stable yet. It keeps changing, keeps adapting, and especially our focus for the next period is to get viable recursion out in a way that is also developer friendly. So that's not trivial. Also, the incentives for decentralized proving are not fairly easy to get right. So it's a matter of process. It's not, there's nothing in the way. It's just we have to work on it.
I think there's another question here.
Yeah, so I'm having a question. My name is Rishabh, and I just wanted to ask, like, how will the interoperability and composability of assets take place in these different rollups? Like, Anna mentioned that there will be shared sequences, but if there are multiple shared sequences, then there will be ecosystems of shared sequences, like there are ecosystems of rollups. So if I want to send some assets from one ecosystem to another, there will not be, basically, how will the assets go there? And second one, will there be atomic transactions available in that case? What's your views?
I mean, also, I don't know if shared sequencers affect this so much, because I'm assuming there's going to be lots of bridges between all the rollups anyways, right? Like,
Well,
I
you're
think
not
the
necessarily
biggest-
using the base layer as your...
If you look at the A16Z's Nakamoto challenge, the first problem noted in Web3 infrastructure is lack of atomic composability between rollups, specifically shared sequencing. And I think there's a lot, like, this is the next step in infrastructure that we kind of need to figure out, because sure, there's going to be if you believe there's going to be 1,000 millions of rollups, and they're all going to use their shared sequencers, great. Now you have like 10 different shared sequencers. The question is, how can you do one block atomic swaps? Otherwise, you're just going to fragment liquidity. I think what was really interesting, I was at NearCon, and one of the cool things they unveiled was like this pre-settlement layer they're doing with EigenLayer, where let's say you have shared sequencer on Arbitrum, shared sequencer on Polygon, and Optimism. You can submit all those transactions to this pre-settlement layer. Make sure if there's any composable swaps you want to do, and like atomic swaps. Once all the transactions are finalized, then you send it to Ethereum. So I think this new thing that we're also looking into is if there's a possibility of pre-settlement layer for your a shared sequencer. So if you are trying to communicate with other ecosystems, I think Polygon CDK is implementing this. You can do atomic swaps, but so far that's a problem in infrastructure that hasn't been solved.
Yeah, on
And I
that,
got- oh, sorry. Hey.
yeah,
I
I
got-
just had a follow-up on that one. So how do you think like it compares with like async composability as compared to atomic composability?
Yeah. I know we're trying to be cut off right now, but atomic composability I think is important for liquidity aggregation. Let's say, for example, you have an off-chain order book. You need to be able to do one block atomic swaps, or your user experience would be horrible because you get price feeds that's within multiple blocks, and then the user checks 4 blocks later, and now the price dropped 10 cents. So you need to have one block atomic swaps for any order book to succeed.
I wouldn't just cut you off, man. I got one more question here, one more here, and after that, we're going to go into the lunch break.
All right, I'll be quick. So probably a question for Rami, but curious to hear your thoughts with all the plays about, snarkifying different runtimes. Like, you got ZK RISC-V instruction sets, ZK LLVM, ZK, WASM, and, all this kind of, levels of snarkification. Can you talk about like what's the trade-off or general pros and cons, and why should project choose you guys as opposed to other players that's snarkifying different runtime?
Sure.
Yeah, I'll show my own project for a while. Why should you choose RISC-0? Well, one thing is maturity. That's what I just spoke about. You can actually deploy and run very complicated projects. The other thing is not everything is done in a VM style as we've done it. So we have some very particular features such as continuations, which allow you to run arbitrarily long programs inside the VM. So there is actual control flow in the RISC-0 ZK VM as opposed to being restricted by a certain circuit width or depth in other systems. And you don't have to do Rust per se. That's just what we support right now. If you can compile something else down to RISC-V, that is how you can also specify your guest binary or your ZK binary. So I'm definitely all for it. You know, it's a project I'm working on. But I would say, yeah, we have very strong tooling support compared to other projects. Does that convince you?
Right. So I have a question about actually compilers and security of this, right? Because with each of your VMs, there's a compiler needed. And how do you make sure that these compilers stay bug-free? Because one huge risk that comes with introducing the new system, whatever kind of the backend is, RISC-V, Move, or WASM, is that, you know, if compiler has a bug, it can impact everybody.
Yeah, so one nice thing is we actually don't have to do much work on the compiler level. We're using pre-existing pipelines to get out RISC-V code. So we don't worry too much about it. We let other developers worry that much about it.
From our side, security is in the VM itself. So sure, we're compiling slowly script to move bytecode, but the VM itself has built-in provers and formal verification. So say, for example, a slowly opcode can't be mapped properly with our transpiler. It'll throw a red flag within the CDK, the SDK itself, and it won't be able to execute the transaction because it doesn't pass the formal verification methods. I think compiling to a non-move VM would be really difficult for us because we don't have the security guarantees that something like WASM would have. But because the VM itself has formal verification, we're able to handle any abnormalities that come up.
One other thing that just I remembered is something we were discussing is verifiable compilation. So you can actually run the Rust compiler inside of the ZK VM and have this verifiable output. Bytecode that is verifiably output by the program that you specified. So even if you have a malicious compiler on your machine, it wouldn't give you the same, or it wouldn't be able to prove its output. So bit of a tangent to your question. Yeah.
I didn't have too much else. Just the more layers that the more things you're putting in between, like obviously it introduces like more risk. So I think that's definitely true.
Great. Okay, well, thank you all for this wonderful panel. Thank you all for joining us.
Anna Rose, thank you for moderating. All right. We're going to have a 30-minute lunch break. We got some food waiting for you guys, some drinks, and I'll come and get you in 30 minutes.
Hello. We have an action-packed schedule after the break. Stay tuned. 5 lightning talks, big panel. Enjoy your lunch.
We're like, how am I going to do this? I just hear that. But like, it was interesting because there's like maybe 15 minutes in, I started to be like, oh, I don't know what question. Do I have to talk about this is actually yeah, they were it's a very good, very good, like direct, like,
security, you can actually probably convince regulators to like less money to launder. No, I mean, if you had okay, all right. So actually, yeah. Sorry. Nice to meet you. Actually, yeah, I think probably have to just like a in the beginning, just like a mouse, just like it helps a lot, like events. Yeah, for sure. How'd it go? They're really good dudes. Yeah, I don't know why they do it all for free, but like I was going to pay their hourly rate. They were like, and I think I had like $200,000. And the difficulty I also had is that like $30,000 after cost, they're like, oh, it's like hard to say because like yeah. So now I'm building building out to and that's really hard. So yeah, because this is the issue now that we're getting into is like the problem is there's this really and I introduced I thought about doing a race yeah. I was like, it's cool, like, but now, like, yeah, so I'm showing us starting to your process. Meeting with stats, to like, let's just do a side chain and show this is like sounds good, man. I'll see you around. So I with those. Yeah, and then my spare time, I do like education sites. Yeah, so there's like these new projects that are basically it looks like some video getting all this relevant and it explains rollups like this. Now I'm using Yeah, it's weird.
Yes. It's cool. I heard something like this.
So say for example, our main wants to raise a few systems, have them move them, and then we'll have sequencer staking move to them as well. So there's actually a economic incentive for us to move our sequencer.
Okay, sweet. And then so if I have if I roll up, let's say I can also stake them. And is the documentation on that is just around like the consensus? What do you guys have?
It's consensus. We're working on revamping some. It hasn't been used yet. There's concerns of like, okay, if you have like say like 10 chains building a network, it doesn't make sense to have like 10 tokens so you can share some network. You probably overload it at that point. So that's what we're looking to like what's the maximum token to stake. But definitely can do 2 to 3 pieces.
Okay, cool. Yeah, I'm about to check that out.
No, I also like love Express, but I think it's like, I was question to you. I know you guys are how long does that take?
So we're looking to integrate next testnet. So the first phase of development right now is we're building out the time boost policy. So we're building out that protocol right now. And that'll take a little bit of time to build out and integrate with the sequencer. Like I think from integrating like
first of all, you guys are way ahead of the
yeah, so we're looking to integrate our arbitrary technology in the next test.
But I mean, that's definitely like my concern is when I go to arbitrage, how do you feel like trading? It's like when's the real city has the assurance to mainnet, and I never get a straight answer. Like either of those.
I would say this. I could probably say this. I think you can probably see espresso next year.
Arbitrage also the token, right?
Yeah, and then
base, like why would they have these?
That's a good question. That's why I really don't know. It's like that's the thing I'm kind of thinking through right now. It's like
but they're never gonna launch tokens.
Yeah, and then the issue with VCs election, and then they are the base. Just a shout out. Yeah, it's just thinking through it. It's like, yeah, I guess decentralization is key, but I think what people are obviously more interested in you is the shares and it's like other chains are not that topic.
I think we actually could be actually if you can make it so that you can stake tokens, like in order to participate in share sequencing, validators need to stake token and create demand for the network token. Now there's an economic incentive for me to share sequencing. So say for example, arbitrage I roll up to lose books. I mean, okay, share sequencer is obviously better than the single point of failure. If I can use my token and create behind demand for it to stake the token, create behind demand for the token to participate in share sequencing, to participate in the network. Now you will have this, and not everyone's doing that. And that's what I'm really interested in. Because see, look, and they're ways ahead of it. They don't really get how we're actually meeting.
So, yeah, I just want to make sure we're talking about the same one.
Yeah. They're the first group that actually thought about that. This makes a lot of sense. Even there, it's a very well off there. You have those three states. Now it's going to be very rich. Cool, it makes sense. But we're sequencing, you still have states. So there's still buy demand ceiling. There's still valuable to and the arbitrage makes sense. Like we're going to have tokens, governance tokens, so there's still like a huge amount of money, and in theory makes sense. But my concern is always like, okay, then you're relying on governance.
Yeah, no, I get it. Like, I totally get it. So I think that's kind of like the big question, right? I think I'm not super familiar with IDTA, but I think IDTA has some of those properties as well, where you can add utility tokens. We're getting feedback on projects. The governance aspect isn't necessarily flying into the eyes of the regulators all the time.
I mean, besides arbitrage, who else can governance tokens? Like, besides the top 0.001%, the average, like this, well, doesn't give a shit about governance.
Yeah.
If you're the VC, you say, my token is the governance. What are you doing?
Yeah, sure. So I do from that.
No, I'm not. I'd love to.
Yeah,
like,
sure.
There's also a lot of stuff looking into share sequencing in terms of time possibility. And I had like these like in-depth talks with it. Like you should look at the newer con like what they just announced. It's very interesting for you guys.
Yeah, so yeah, we saw that as well, and that's kind of like the fast finality layer. It's really interesting
because if you have this thing, let's say you buy this thing, $1 million, cool. Yeah, sure. You're seeing all these groups. How are you getting this swaps? Increase our fragmentation. If there's a pre-settlement layer or somewhere to do atomic swaps, you just solve the position.
Yeah, we're actually releasing a lot of like posts on interop, so like I should definitely check it out.
I looked like collaborators. Yeah, putting together small projects like pre-settlement. I love to collaborate.
Let me talk to collaborate together on the business. I'll talk to our engineering team.
Where is based? Is anyone in New York living on
Ben is yeah, I'll enjoy it.
Sounds good. I appreciate it, of course.
Yeah, you should have said no kids Didn't they, Polygon is like they're a part of Polygon and it's like branched out, yeah. I actually got what? Yeah, you should. You know, like, no.
Yeah, that seems to work.
Everything's working. All right.
Okay, so
Karsten, everybody.
yeah, so I'm here to talk about Katesi, which is an alternative RISC-V based virtual machine. And just to kind of like keep it short, maybe very short, the Katesi machine is a RISC-V emulator. It runs completely deterministically. If you start out in the same starting state, you'll end up in the same ending state. It's what we call, let's say, general purpose, as in it implements the full RISC-V 64-bit GC, which means basically you can run Ubuntu inside it if you want to. It's one of those things that's written in C++. It's the LGPL licensed. It runs on Wasm. It runs on Linux. It runs on Mac. And as of a couple of days ago, it runs on MS-DOS, in case you actually wanted to have that. And one of the things it kind of comes with is that it comes with 64-bit memory addressability, which means that there's more than enough space in the virtual machine for you to do anything you could possibly think of. And it's one of those, it's been developing since 2018 and it's still being developed. One of the things about this virtual machine is that the entire state of the virtual machine is memory. It can be Merkleized, as in that you can basically represent the entire state of the virtual machine with a single hash. And you can kind of like stop and start it, you can persist it, you can snapshot it, you can roll it back. And that basically means that it's possible to use it in, for example, an optimistic roll-up kind of manner, where you kind of like getting to the point of disagreement and then running one particular step and proving to a blockchain, which then runs one single RISC-V instruction. And I'll build a little bit into it here. And it's kind of programmable. You can adapt it into even ZK environments. We have been trying to do something as crazy as trying to run Linux inside ZK proof using RISC-0 technology, where we basically stuffed our Katesi machine, our virtual machine, inside RISC-0. And it takes 3 days to kind of ZK proof that you're booting Linux, but at least it works now, right? And basically, I think that the ultimate runtime, kind of like for application, is kind of like a general purpose processor virtual machine that can run the full 64-bit OS. And if you're interested to kind of see the source code of it or the white paper, this is kind of like the links you can go to. So why Katesi? Why does Katesi matter, right? And I believe it matters because it's less of a leap for most developers to actually jump into using using blockchain. If you know a bit of TypeScript, if you know a little bit of JavaScript, even PHP or something like that, you can start using Katesi. Because why can't we actually go in and, let's say, develop application change just with the same mindset that we're approaching things like AWS, Heroku, or Vercel, and so on, right? And one of the things we kind of get for free also was mentioned in my earlier talk, that we get compilers, we get tooling, we get debuggers, we get testing frameworks. We don't need to reinvent this whole thing again. And at the same time, we also get to benefit from that. Well, people have spent the last almost 50 years improving these compilers, these frameworks, these libraries, et cetera, et cetera. And this is maybe a bit of a controversial opinion, but since we have a panel, I thought I might as well get to it, that I believe that if we're looking kind of like back at the EVM in the last like 5 years or more of the EVM, it has kind of like ended up with a trail of dead projects, dead languages, broken developer experience. And I kind of like believe that this causes basically a terrifying and heavy developer experience. And I think that it doesn't help because we also need to have not just completely specialized, almost high priest-like smart contract writers. We also need the average people, the people who want to build, let's say, decentralized message boards or other kind of like small things like this. And this is where I think the Katesi fits in. Just go with it. I also think that us who's working in virtual machine business and rollups and so on, we have many shared challenges. Like, for example, how do we actually talk to each other? We have many different technologies. How do we communicate? How we bridge information between each other? Things about sequencers that now becoming much more relevant with projects like Celestia and Espresso Sequencer. How do we build those kind of like virtual machine interfaces for block builders, in, for example, in publisher, proposer builder separation, for example? How do we deal with atomic cross rollup transactions in the same way where it doesn't become a frustrating experience for the users? How do we deal with the fact that, well, there's going to be just as many sequencers as there's rollups out there, or at least as many as it seems like with technology? Things about indexing, archiving, and also the probably a problem that most of us share here. we are really the experts in making rollup or blockchain virtual machines, and there's really nobody out there who can actually really help us to audit it. So maybe we can start the practice of, let's say, starting to audit each other's VMs, et cetera, and things about, is there a way we can use restaking, eigenlayer to kind of like make things cross virtual machine more better, and about proto-dunk sharding, because there's not a lot of blobs available every single time on Ethereum, and kind of like topics that, for sake of collaboration, we can kind of like get to. And yeah, compared to many other talks today, mine is short. So if you want to talk more, you can poke me on Telegram, find somewhere with a Cartesi t-shirt, read more about Cartesi machine or about Cartesi, and that's pretty much it. Any questions?
Sorry? That's a great idea. Let's give a round of applause for Karsten. Any questions? He beat you to it. Sorry. I'll be right there.
Thanks for the talk. I wanted to understand what your system of proving inputs into the VM looks like. So say like the Ethereum virtual machine, or you taking like state from Ethereum, proving the correctness of that within a Cartesi VM?
So the way to kind of think about how input makes it inside a Cartesi machine is basically you have the state hash, right? It represents the memory. What you basically want to do is kind of stitch the new data that comes in from the Ethereum, in this particular case, into the memory image. So you end up basically with a new hash of the machine state. So then basically everybody agrees on this is the starting state of the machine, right? And then we can kind of like replicate the computation. We can go in and let's say, if there's a disagreement about it, we can find out where did we disagree. But in general, it's just basically like writing into memory. And from point of view of the client, it's basically a JSON RPC call into the virtual machine, write this into memory, that's it. And get the proofs for actually doing so. Does that answer your question?
Yeah, hey, so what I was gonna ask is, I really like the part where you told about collaboration, you know, so we have a bunch of VM specialists, and you also talked about doing Cartesi machine proofs using RISC-0, who are also here. So could you talk more about that?
Yeah, so if we're thinking a little bit about, like, it's completely crazy to start up a machine all the time and like booting up Linux and then proving basically the whole execution of that. Because most transaction processing that actually will go in this particular case is that I'll boot up Linux, I'll boot up my application, and kind of like something like AWS Lambda is doing, I'll snapshot at that point. I don't even never ever need to prove that I booted up Linux again. So when I actually get a transaction in that I'm actually modifying, I can prove that tiny piece, which actually not that many kind of like full-blown general purpose cycles, and make a proof of out of that. So this is one way to kind of like bring, let's say, we don't need to reinvent the entire operating system, let's say, interface. We can go ahead and basically use what's already out there. Of course, as somebody said earlier, the more layers you have, the more probabilities of issues there are. But at the same time, we can also go in and now suddenly do things like, let's say, ZK proving that you can run an entire Rust compilation or kernel build. I have done, let's say, reproducible Docker containers with this. There's many interesting things you can do when you can actually have a full machine that's actually complete and can run Linux in it.
Hi, just to be clear, does the user boot up a Linux machine in their browser or computer, or is the sequencer basically a Linux machine?
Yeah, so let me take it from this perspective, right? Like the virtual machine doesn't really care about what sequencer is attached to, right? So it could be Expresso sequencer. We have recently done a demo where we put 17 megabytes of data through the Expresso sequencer, video decoded and showed it with ASCII art, and you happen to be the RISC, right? So you can run the Cartesi machine in a browser if you want to. You'll naturally take in all the input to kind of like get to the same state, but in most cases, people will want to kind of like, you do it like, for example, it's Optimism is doing it at the moment, where you're kind of optimistically proving to the blockchain, this is the state after a certain amount of inputs. So this is what kind of like optimistic proving is about, right? That after, let's say, everybody has the possibility to dispute what the computation result is, if nobody successfully challenged it, it becomes the computation result. So it kind of depends on how long do you want to wait for the result. Of course, there's possibility to have something like, let's say that you have a node you connect to and kind of check what the latest state is, but there's kind of like also the possibility that these things might eventually also even provide ZK proofs that the execution was actually correct when you're querying about a particular piece of data.
So in the optimistic case, do you have race conditions wherein user A might have taken the current state of the blockchain, whereas user B asked a node which didn't fully know, hasn't sunk up yet, and both of them run their transactions on the same machine?
I don't think there's any, so this is replicated computing, right? So if you're a validator, you're able to replicate the execution completely. If you're dishonest, you'll try to modify it. Like, let's say that I'm getting $1 billion instead of you, right? But the blockchain basically helps ordering the transactions, right? And then basically the Katissa machine, in this particular case, takes the transactions, runs them in there, updates the state of the machine, or updates some outside state of it, which for example could be an IPFS database or something like that. And so there's always an ordering, an exact, let's say, deterministic order of how the virtual machine is supposed to run.
All right. Karsten, thank you very much.
Yep.
Then our next speaker, Nick, CEO of Fuel. Give him a round of applause, please. There you go. I'll grab you the clicker. All right.
Some slippery stairs. All right, so I wanted to do a highly technical presentation describing every aspect of our register design, our memory, the way things work, the way calls work, the way fraud proving works, the way introspection works. But instead, I'm just going to tell you a story, and you can look that up later yourself because I only have 7 minutes. So, so yeah, to start it off, if you guys can hear me okay. So the Fuel VM, what the hell is this? Basically for today's agenda, we'll just go over some more burning questions that I think a lot of people have about what our VM is and how we've designed it. Starting off with UTXOs, then going over to how we do smart contracts and UTXOs, because that's always a big question. P2SH and predicates, and then as well how Fuel is trying to design the foundation for a more modular world for blockchain. So to start it off, the EVM is great, but very convoluted and really complicated. So it was designed, unfortunately, very quickly. And I know because I was sort of like at the aftermath of when they did it, and it was very fast. And unfortunately, it came with a lot of interesting baggage. Well, it served its purpose and moved blockchain forward tremendously. Like I think we all know we could probably do something maybe a little more interesting and probably try something different. So, so with Fuel particularly, a big thing to kind of think about here is basically like the power of some of the Bitcoin transaction model, but with really the expressiveness and the flexibility of Ethereum. So that's basically how you could think about the Fuel VM in and of itself. So fundamentally with UTXOs, it's a scary word, but really it's just to describe what we kind of consider as state access lists. So effectively just describing what areas of state you're touching in a virtual machine, and then basically describing how that's going to be changed. So like a typical model just has some inputs and some outputs, and basically each transaction is sort of defining a state transition, you could say. So just transitioning from the previous state where everyone had this to another state where everyone else had something else. So it's really quite simple. It's just the word, you kind of say it and then you lose people. So to demystify it, it's really dumb and simple, and it's basically just this. So a really nice side effect and something that the Fuel VM tries to do is reduce a lot of burden that we have with blockchain, which typically comes from state growth. So if you know anything about how Ethereum's designed and how a lot of blockchains are designed, the state can be immense and enormous. And Effectively, and I'll show you in a second, this really constrains our ability to sustainably scale as a technology and as a group. So blockchains that use a UTXO model can benefit from some really nice properties. One is, if you know anything about blockchains, it doesn't need to have a global state root, but it can still be valid and still like client provable, which is a huge win if you're looking at how to build a blockchain. If you need to serialize every single state transition into a giant Merkle tree, it's really prohibitive, very expensive, and it's not great. So we remove that with a UTXO model, which is really cool. The second thing is UTXOs provide a state minimized alternative to smart contracts. So in RVM, we try to get developers to push away from using smart contracts, even though you have full flexible Ethereum style smart contracts. We try to give you more tools. And as well, each UTXO, when it's spent, only takes up a single state element. And again, it retains like client provability. So this is a very, very important factor with blockchain design. And it's something that, unfortunately, many blockchains succumb to. So state reduction is a big piece. But I'm not going to spend a lot of time on it here. Tomorrow at L2 Day, I'm going to talk about how we basically solve or reduce the state growth problem significantly using this technique. But anyway, that's one big benefit. And as you can see, Peter, the developer of Go Ethereum, really doesn't like state and talks about it all the time, and basically says that, you know, if we don't deal with these kinds of things, we don't find other ways to address it, we're going to see an existential issue with Ethereum at their current node requirements. So in addition, the Fuel virtual machine is also designed for parallel processing. So this is a really important feature of, I would say, any modern virtual machine. And you really want to be able to use all the power of your machine to process transactions. So in a sense, UTXOs enable us to do this because they act as a state access list. So this means that, you know, you can analyze a block and you can just say, okay, I know these transactions are going to touch these pieces, and thus we can process them on these threads, and they're not going to bother each other. So very important. Second thing is, not only can you process in parallel within a block, but you can process across blocks in parallel too. So you get really nice properties in terms of parallelism with using a state access model like UTXOs. So in terms of the results, and I know TPS is a horrible number and we should never really discuss it, but fuck it, everyone asked me for the TPS, so I'm going to give you the TPS. So basically, the way to think about this is per core right now on an unoptimized node that we have, we can verify about 7,000 transactions per second. On an 8-core, up to 58,000. And because of the way our model's designed and also the way that UTXOs work, we're able to get really nice compression properties, which will allow us to post about 2,500 TPS a second on Ethereum DA, given that we used all the DA on Ethereum. But effectively, that's what we can process at the limit. And so effectively large numbers, but again, TPS is a horrible metric, so don't ever use it unless you have to, unfortunately, just say it once. But anyway, there, I said it once. So in terms of another thing that's very, very important, so the Fuel VM also brings something that I think is incredibly important to the design of blockchains in general, which is very rich light clients. So light client support allows just regular people to be able to validate and introspect different pieces of the chain. So with Fuel, we redesigned things like the block header and the transaction structure such that it's very easy to introspect everything that's going on within the system, such that even on-chain light clients are very approachable. They're very easy. It's really just verifying a few light Merkle proofs, so it's nothing too intense. And so when you do things from scratch and you rebuild, you get to address and fix a lot of these shortcomings that you typically see in these blockchain systems. So rich light clients allow for really great cross-chain introspection. So effectively, one rollup can really take a look at what's happening in another rollup. And this is very, very important if you want to have really nice properties of bridging between rollups. So a lot of the Fuel VM design is designed to minimize state, and it's also designed to have really nice properties of introspection. So light data introspection is very important to us in terms of how this will work. And ultimately what this means is that bridging and doing trustless bridging with no multi-sigs and everything else is very, very approachable, even in the optimistic setting, without ZK, without anything complicated. It's just very easy to see what's going on all the time. Another thing that we focus on in our asset model in UTXOs is having multiple native assets. So with Ethereum, unfortunately, the only native asset is Ether, which is really, really constraining. Every other asset is at the application level, and this really constrains the kinds of designs that you can actually put together with, with a blockchain. So in the Fuel VM, all assets are or can be at the native level, and this allows for a really interesting property of settling lots of different kinds of transactions with lots of different assets and lots of different criteria for settlement. So everything coming off of exchanges really benefits from this, because a lot of the time you just need to send asset here, send asset there. And that's a lot of what blockchain does. And so we really optimize for that in terms of our native model itself. And as well, this also means not only settling fungible tokens, but also NFTs. So this is another question we get all the time, which is UTXOs and smart contracts, and how effectively this whole thing with Cardano really kind of skewed everyone's perspective quite a lot in terms of how this actually functions. But basically, a big thing that came up was Cardano designed this smart contract model that was really blocking in terms of how it was processed, and it ended up creating a horrible user experience, thus scarring UTXOs for the end of time for everyone else that actually doesn't have this issue. So if you ask, which was why I was particularly angry with Cardano people. Nothing against Cardano people. Just this was a bad design decision. Is it possible to have really nice Ethereum-style malleable state smart contracts in a VM? The answer is absolutely. And this is another funny one that I found too. But effectively, their scientists are working on it. Effectively, UTXO smart contracts are very possible. So you can see here the inputs act as a nice state access list. You have multiple inputs. One's a contract input, in this case how the Fuel VM works. And then when you're basically defining the output, you're notating two things, the state and the receipt route. But the user doesn't do that. The block producer does that. And so that gives you that malleability while still having all of the niceties of a state access list like system like Fuel. So yes, we can do Ethereum style smart contracts, and again, state is malleable, et cetera, et cetera. And it supports all the things that you like about doing EVM style smart contracts, but doing it in a way that, again, can be parallel processed, et cetera. So another nice thing that we brought over from the Bitcoin space is effectively a concept of spending conditions. And so pay to script hashes is something that Bitcoin had before because of its UTXO model. This effectively allows you to send assets to a script that's a spending condition. And with this, you basically are trading off using a smart contract and state for doing something more over bandwidth and just using something that's lighter. And in my presentation tomorrow, I'll go into why that actually fundamentally addresses huge issues of state growth and kind of blockchain IO issues. But in this presentation, it's very good. It's very state minimized. The next thing is that this also acts as effective account abstraction. So with Fuel, you can sign at the native level with Solana wallet, with P256, with any kind of signing curve you want, and it's supported at the native level and fluently in a multi-actor transaction, which is very, very nice when you have lots of different people settling lots of different things. And the code for this is actually prunable, so it doesn't need to be stored. So again, it's very light on processing. And Fuel predicates are really our version of this pay to script hash idea. And so you have expressiveness, but we keep them basically atomic so that we can not only process the block in parallel, but we can process all of the predicates in parallel too. And so again, this powers everything. And it can not only do multi-sigs and native account abstraction, but it can actually also fundamentally do order books, which is very cool. So it's a nice side effect. So that will be the most state minimized possible order book you could ever construct. And again, each UTXO only takes up one state element. So in terms of improving on the existing blockchain stuff and moving it over into something more modern, Fuel really does the job. In terms of being kind of a foundational layer for blockchains and blockchain VMs, I know I've covered a lot of different things, but the main thing is that on the horizon, there's also a lot of stuff to look forward to. So Native meta transactions, or in this case, like fee abstraction, so not having to be stuck with fees, but doing that in a very efficient way at the very lowest level will be very fundamental for Fuel. As well, things like ZK proving with UTXOs are it's much better in the sense that on the ZK side of things, you really want things to be more atomic, and that way you can do more parallelism with ZK itself. So I'm sure like Bobbin and the Maiden team will give you a good rundown of why UTXOs are a great model for that. And as well, UTXOs are also fantastic for privacy properties, and as well for settling from intents. So settling down from, you have a bunch of users and they have a bunch of intents that they would like to eventually settle. The multi-asset model of the Fuel VM is very much like that. So that's basically it. And again, I would say that, you know, I could have talked about all the very detailed specifics of our VM and how it works in the word sizes and everything else, but I just wanted to cover more of the major stuff that people typically ask. And if you want to learn about how our register VM works or all this other stuff, just read the specs, because it'll be a way better presentation than I can give in 7 minutes. So, all right, thank you. Thank you, everyone. Yeah.
All right. Do we have any questions? Questions? Okay.
Nope.
Very straightforward.
Yep.
Okay. Oh, wait. last minute entry.
Yeah, I was taking some notes while you were talking. So great presentation, Nick. Really quite impressed after we had a talk outside. You did mention something about having native support for particular signatures. Is that what you said?
Yeah.
And then you mentioned some of the signatures in Solana. Can you talk a bit more about that?
Yeah, so so in terms of different native signing support, you kind of don't want to burden the user with having to switch wallets or switch keys. And so you want to support whatever wallets they have. So most people in the room actually have a hardware wallet that they're carrying all the time, and it's their iPhone typically, or Android maybe. And they actually don't need another hardware wallet for a lot of different cases. So being able to support that signing type at the native level is very important if we wanted to get, say, the whole room to adopt a new piece of technology. So in a sense, you want to support the signing technology that people have, and that could be MetaMask, that could be you know, like a Cosmos wallet, or it could be you know, just a hardware wallet that they have in their pocket. Yeah.
Interesting, because we also talked about having sort of native app chains that settle on Fuel.
Yeah.
Right. Okay. Got it.
Yeah.
Great. Thanks.
Cool. Any other questions? Thoughts? Oh.
So for the pay-to-script hash opcode, do you also support different kinds of hashing functions in order to enable atomic swaps and the other things with a wide range of other layer 1 blockchains?
Yeah, 100%. So within the predicate itself, you can tap into pretty much anything in the VM that doesn't touch state. So the predicate tries to remain a stateless, effectively atomic script. So hashing, all that kind of execution is fully available. The Fuel VM also has some very interesting properties of self-introspection. So in a predicate itself, you can actually take a look at the transaction itself, because it'll be put in memory for you. So these little things allow you to do really cool stuff. So you can introspect your own transaction, look at the inputs, look at any aspect of it, hash, verify, Merkle proof, whatever, and then that becomes your spending condition. So effectively, it's providing the developer more ways to do things that are outside of the context of smart contracts. Because again, you can do everything with smart contracts, but as some of the devs in the room probably know, it's absolutely horrible to try to jam everything through smart contract transactions. Like, it basically ruins all forms of scalability. So yeah, that's kind of the idea. So 100%. Yeah. Yeah.
I have a follow-up question. I think there's a lot of talk currently. There's like EAP 7212, I believe, which essentially talks about using SCCP's 256R1, which is commonly used for biometrics and enclaves.
Yeah.
And I was wondering if you're looking to support that now that the industry is kind of...
I'm actually demoing that tomorrow.
Ooh,
Yeah.
okay, nice.
So, and we've supported that for a few months already. We just didn't write the WebAuthn script. So I spent the last few days writing that, and it was absolute hell, but we've got it running.
Nice.
got it verifying. Yeah.
Yeah,
Woo!
that's critical for onboarding, just in case. You could essentially create a wallet using biometrics, and the user doesn't have to be exposed to the private keys.
Yeah, so that you'll have with full native support, and it'll also be tooled in our SDKs too.
That's huge.
Yeah.
Last context. This is pretty cool because currently in the Ethereum world, people are talking about implementing SCP-256-R1 on a layer 2 and then putting it on the layer 1. So while they're supporting it natively here. Cool.
Yeah, yeah.
Thanks.
Yeah.
All right.
All right.
Cool.
Thank you, Nick.
All right, thanks everyone.
Thank you so much.
Then I would like to invite our next speaker on stage, Raul from Off-Chain Labs. There you go. Thank you. And perfect. 6 minutes.
Yeah, sure. Okay, great. Okay, hello everyone. My name is Raul. I'm an engineer at Off-Chain Labs, the team that is behind the Arbitrum Layer 2. And I'm also a maintainer of the Prism client, which runs Ethereum proof of stake today. So today we'll be talking about Arbitrum Stylus, which is a technology that we recently announced, and it's live on testnet. It allows developers to write Ethereum equivalent smart contracts in some of their favorite programming languages, and basically almost any language that compiles to WebAssembly, which is really exciting. So the EVM is, of course, meant to be small and easy to price. And the bytecode can be fairly small. It looks very transparent. It's simple. But of course, we've had so many developers adopt Solidity as the primary language, despite us having others such as Viper and such others that are coming up, such as Felang. And an unfortunate reality is that, of course, in the past we've seen situations where we would see DeFi hacks almost daily or weekly. And many of these are, of course, a result of the design decisions that came from implementing the EVM. But I'm not here to bash the EVM or say that we need to completely abandon it. Instead, we highly believe that the EVM is here to stay. And we know that the developer experience, the tooling that has been invested over many years, is only going to grow stronger over time. So instead of approaching the problem from the angle of, hey, can we just introduce something completely different, we think about it, how can we give existing Solidity and EVM developers more superpowers? And of course, many projects have introduced alternative VMs, which is of course the theme of the summit, and many with success as has been demonstrated, which is awesome. But we believe the network effects are not going away, and there are network effects at many different layers here, right? So there are network effects at the tooling layer, at the application layer, in the actual VM layer, of course, and it's about which ones of these network effects do we want to maintain moving forward. So the question is, to be or not to be? Do we need to abandon it entirely, or can we do something better with the existing EVM? Today, Ethereum is its own little sandbox, kind of, like developers have to write in languages that then compile into EVM bytecode. And we're leaving out a huge swath of developers that are already used to many existing programming languages and backend languages. So the answer, the question is, why not both? So introducing Arbitrum Stylus. So Stylus is a next generation programming environment for Arbitrum chains. It allows developers to write Rust, C, C++, Zig, more, you name it. You can add support for it yourself. It's fully EVM interoperable. And of course, in the EVM, some benchmarks that we have is in the time that the EVM can do 7 single add instructions, with Stylus, we're able to do complete rounds of hashing in a simple hash such as SIP hash, but the benefits don't end there. Because Arbitrum today proves computation over WebAssembly, which is kind of the bytecode that we choose to compile to for many reasons, we ask ourselves the question, can we support execution of WebAssembly smart contracts in addition to EVM bytecode? And we believe that WebAssembly is really a powerful technology that will continue to shape the future. There's a famous quote that we like to look at from Solomon Hykes, the founder of Docker, that said that if WebAssembly and WASI, which is a standard library for WASM, existed, back when they were starting Docker, they probably wouldn't have needed to do that at all, which is pretty mind-blowing. So we call this EVM+. So one chain, multiple languages, fully composable, and it's not a new L2. We have one single state transition and one single state tree, which is the Ethereum state tree, one single database, and there is nothing like it. Stylus is much faster. Instead of being interpreted, such as the EVM is in many of the popular Ethereum clients, Stylus leverages some of the existing optimizations that exist for WebAssembly backends using the Wasmer runtime. So we have a 73x faster runtime against Kautuk, for example. And surprisingly, some of the benchmarks around memory shows that Stylus can be 100 to 500x cheaper and more efficient in memory usage, even for medium or smaller size contracts. This slashes fees for users and enables things that just weren't previously possible. Examples are advanced cryptography, precompile research. Instead of waiting many years for Ethereum core devs to ship a new precompile, you can just do it in your own language and get all of that included, and also other heavy computation. What we're most excited about is that you can use the tools you're comfortable with, right? So you don't need to learn a brand new language. You don't need to learn our own DSL of Rust, if you say. Like you can basically do things however you do things today. If you want to access information about the EVM, we provide you with this syscall-like host set of functions, such as say access to storage, calling contracts, and you're able to write basically pure Rust code. And the most important part is that we have EVM equivalence in the sense of how we interoperate with the standards that exist. That means that developers or users could be talking to a smart contract with MetaMask or with their favorite tooling and not know that underneath the hood, it's written in Rust. And that contract is talking to another language that was written in Solidity. And that contract is talking to another one that was written in C. So we have an amazing level of customization and choices for developers to build upon these their own projects. As an example here, this contract is calling another one, and this is written in Solidity, but the one it's interacting to is in Rust. So there is no extra tooling required. It just works. We believe that EVM compatibility is not the ceiling, but rather the floor. Sorry, I think I messed that up, but anyways. Testnet is live, so you can try out Stylus today for yourself. We have documentation where you can start building, you can deploy some example applications, and really test out how different this is versus writing your own implementations in Solidity. The best part is that you can take existing projects, such as Rust crates or C projects, compile them directly, deploy them on chain, and just basically have that tooling available for you on Arbitrum testnet, which is really exciting. We have first-class support for Rust and C, and because the API to the EVM is so low level, anyone can write a custom framework on top of this. Anyone can write an SDK. It's permissionless. You can do it yourself. Some people started already writing, more C SDKs, and there is Zig SDKs as well available for people to use. We also have examples of Ethereum standards, such as ERC20 tokens, that are implemented with Stylus and have EVM equivalents at the storage layer and at the ABI layer. So you're able to interact with them, mint them, transfer them any way you would, and this contract is written in Rust. That means you can see transactions in Etherscan, you can see that it emits the same events that an ERC20 token in Solidity would, and all of that is available to developers right off the bat. If you want to add other programming languages, it's super easy. Adding support for Zig, which is a brand new, relatively brand new language that is aimed to be a successor to C, took me around 16 lines of code. And anyone can do this. So you can even write your contracts in assembly script, or you can do it in a functional programming language, if you will, and you can deploy that to Arbitrum Stylus. And there, the sky is the limit. Do you need something low level? So Stylus provides a very low level entry point, which is just bytes in and bytes out. And you can get started and just go wild. You can do anything you want here. Some examples, there are some benchmarks of showing hyper-optimized smart contracts in UL, for example, for EVM bytecode, and running a similar non-optimized version of a contract in Rust. And stylus really does shine the number of iterations, and the more expensive the computation becomes. Moreover, stylus programs can export ABI interfaces that are Solidity equivalent. So in this example, I deployed a BLS signature verification contract in Rust, and I'm able to call it using the Solidity interface, and opens up a ton of opportunities at the application layer that just weren't there before. We also have developer tutorials, so we have a lot of information. And all you have to do is navigate to arbitrum.io/stylus. And here's a capybara. Thank you.
Thanks, Raul. Don't go yet, don't go yet. Maybe we got some questions. Yes, sir.
Yeah, hey, so very nice. I have a question about metering. So how does metering work on stylus, essentially? Thank you.
Sorry, can you repeat that?
Metering, like
metering, gas
yes.
metering. Yeah, that's a great question. So a big challenge of dealing with WebAssembly is how do you effectively meter the computation in order for, to appropriately gas price things. So of course, gas metering is different than the EVM gas model. We have done a lot of metering on a lot of benchmarks to better understand how to price each WASM opcode. But stylus actually does a lot of cross-checking. It does depth checking. It does memory checking. It does stack overflow checking. And we basically walk the contract bytecode that you deploy. We sanitize it, make sure that it matches all those items before it can be deployed on chain. So we have a very strong set of checks, unbounded execution, of course, and we feel confident that this is something that that we have figured out. So. Yeah, and you can look at our metering code and middlewares as well. It's all open source. Yeah.
Any other questions? I could have stayed where I was.
Hi, great presentation. WASM is known to be quite hard to deal with in terms of error handling. I'm curious, like EVM, a lot of reverts happen. Has it been a pain to handle reverts for stylus, and how did you do it?
Yeah, excellent question. So the nice thing about stylus is that you can run your Rust code as a normal Rust program, and you can probably inject it with a backend. So you can use some interface. We plan to support things like Foundry, like Forge, and Ganache, and things like this. So from there, you'll be able to easily do that. So you can run it as a native binary, or you can run it as a WASM binary. It's really helpful to run in native mode for debugging, but in WASM, if you use the stylus SDK, we support the Solidity ABI model, we support Solidity storage types and everything. So reverts and execution debugging will be very similar to your Solidity debugging experience. And we hope that with tools like Foundry, you'll be able to just debug it like you would any normal smart contract.
So, quick question. So this would still work with Solidity-based proxies, right? I would be able to deploy this and point my regular, let's say, Diamond proxy to use this as a facet, right?
Yes, that is correct. That's a very exciting use case. So you can swap out something that's in Solidity and upgrade that to a Rust contract, and it will be equivalent.
And I got one more question for you.
Sure. Yeah.
Hey, it's me again. Can you hear me well?
Yes.
Yes. So I'm also wondering about standard library support, like for example in Rust. Can you code using the standard library, or would you need in Rust to use no STD or something like that?
Yes, you can use the standard library. Of course, you can't use things that are non-deterministic. You can't. Floating point support is coming, so that's going to be a big thing. And yes, you can use the standard library. You can use it with no standard library, which is really exciting. Something that we think is really powerful is that somebody could deploy the Rust standard library as a standalone thing to Arbitrum stylus, and then programs could link against it, kind of like how they, how we do dynamic linking and linking in general in the Solidity ABI model. So that's a possibility for sure.
All right. Thank you, Raul.
Thank you.
Thanks, man. And our next speaker is Bobin from Polygon. There you are.
Thank you. Hey, everyone. very excited to be here. All right, so my talk today is about Maiden VM. This is the heart of Polygon Maiden rollup. I will actually not talk a lot about the actual rollup aspects of this. Polygon Maiden VM is kind of general purpose, and you can run many rollups with it. The way it works actually is like you can deploy different OS on this, and the OS defines what the rollup is. So like things like UTXOs I'm very excited about, but they're not actually encoded in the VM itself. This is something that could encode in the OS that runs on it. And so like Polygon Maiden OS, the one that runs the rollup is the one that determines like the structure of the rollup and all of that. But I did, before kind of going into details of Polygon Maiden, I want to give an introduction of what the ZK VM is, and probably it's familiar to most of you, but I think it's good to set the context. So let's start with a regular VM. Regular VM basically is just a state machine where you start with some state, you apply some program to the state, you execute something, and then you get the output state. This is like a very, very basic thing. With the ZK VM, we get a couple more boxes here. So one of the boxes is you also get the proof of execution at the end. So as you execute some program, at the end you get this proof, and nobody else needs to execute this program again. They just like verify the proof and know that this set of inputs, if you apply this program, will lead to this set of outputs. The other thing that we get is that something called witness or private inputs. So you don't have to necessarily, that could be private data that you don't want to reveal, some secret to whoever needs to verify the program execution, or it could be something that you use for compression. As an example, you can probably, let's say, this is a transaction that you are executing, and as part of the transaction, you need to verify signature. So one of the nice things is that you could provide transaction or signature as part of the witness, and then nobody else needs to like actually verify the signature. They just verify the proof. Signature is already verified for them as part of this proof. And then we can do some kinds of optimizations. We like frequently don't actually need to provide the full set of inputs and the full set of outputs as part of the inputs, or even the program itself. We just provide commitments to the inputs, to the outputs, and to the program, and provide the actual state, the input and output states, and the program code via this witness. This allows us to compress things even more, like you only provide 32 bytes for a given program, for example, and that's that describes the entire program because everything else is provided non-deterministically through the witness. All right. One very important aspect is proof is very fast to verify. It doesn't matter almost how long the execution takes of the actual program. The proof takes exponentially less time to verify. It takes much more time to create, so like the proving is costly, but the verification is cheap. So you can run the VM for 1,000 cycles, or for 1,000,000 cycles, or even maybe for 1,000,000,000 cycles, although for that you need a lot of memory. But let's say, regardless of how long the actual execution takes, the difference in verifying the proof is going to be very small. Like you could verify one proof in 1 millisecond, the other one in 2 milliseconds, and maybe like the other one would be in like 2.5 milliseconds or whatever. So it's like really talking about milliseconds here for verifying almost arbitrary length computations. All right, one of the things that we want to answer, like when we build a ZK VM, or I guess any VM in general, is what instruction set we want to support, what we're going to want to go with. So like one option is like choose something mainstream, RISC-V, or you can choose WebAssembly. The other one you can say, we're going to be EVM equivalent. And then the other one is like we can build something that's ZK optimized, or you can say maybe specifically optimized for some other use case. And then there are a set of trade-offs that come with each choice. So for example, if you choose tooling, if you go with something that is mainstream, you have a ton of tools available. There is like, for Rust, WebAssembly, RISC-V, you have the entire tool chains built out already. If you go with EVM equivalents, you have already a lot of tools. Like it's not as many, or it's not as rich of an ecosystem as for traditional languages or widely adopted languages, but it is, it's there. You have Foundry, Truffle, whatever, like a bunch of different tools. And then if you go with something that you build yourself, obviously you have you have to build everything from scratch. The other one is like, do you go with something that is blockchain focused? And this is like an interesting thing because, if you go with RISC-V or WASM, this is obviously not blockchain focused. They need to do extra things to make sure they work well in the context of a blockchain. There needs to be some modifications. If you go with EVM equivalents, obviously this is already blockchain focused by definition. And then if you're building your own thing, you can also define like the parameters and make it blockchain focused as much as you want. And then this is specifically performance in the context of ZK, how easy it is to generate proofs. So for mainstream, it depends on which instruction set you go with. For something like RISC-V, maybe it's more efficient. Like if you try to do x86, it's like going to be very inefficient. RISC-V may be a bit more efficient. WASM is somewhere in the middle probably. But generally, those instruction sets were not built for ZK friendliness, so it's going to be a bit more costly to generate proofs. EVM was not built for ZK friendliness, and at Polygon we have ZK EVM, which does generate proofs, but it is, obviously the computations are costly. So it's not something that you would be able to run in a browser or on a mobile device, at least not anytime soon. And then lastly, if you're building your own instruction sets, you're free to optimize as much as you want. All right, so a quick overview of Maiden VM. So first I want to say, like, what are the things that we wanted to achieve with Maiden VM? So first, kind of table stakes in a kind of smart contract world or regular world, but in the ZK it's a big deal, like build something that is Turing complete. Basically, you can execute any program. Frequently, especially in a circuit model, you're limited. You can't execute arbitrary programs. You have to account for the upper end or whatever, the worst case, and then you build your circuit for that. But we wanted to have something that is Turing complete. The second one is we want to have something blockchain focused. So we designed ISA specifically that targets use cases or optimizes for things that are relevant for blockchains. And I'll list some of the examples later, I think. But one of the things like verifying Merkle proofs should be efficient, hashing should be efficient, like some certain operations should be efficient, and so forth. So we gave priority to those. We built this for ZK friendliness, so we designed specifically the instruction set and the operations so we can prove them easily in the ZK context. Our proofs are very efficient. You can execute. I mean, I'll show some performance numbers. The ZK VMs are still much slower than regular VMs, but as far as the ZK VMs go, Maiden is pretty efficient. One of the core goals for us, and this also will bleed into the next point that I'll make, is safe composability. What I want to mention by this is that you can execute untrusted programs. So, and actually let me show the next one. So we want to have, like, one of the goals for Maiden rollup, and therefore it bleeds into Maiden VM design, is that we want to have privacy. And to have privacy, you need to execute programs that the blockchain operator or the block producer does not have any concept about. They are private. People kind of define them and just put a commitment on chain. So you need to be able to execute programs that are not known, or at least verify their execution. And therefore, we want to make sure that you can compose programs that you have no idea what they do with programs that you do know what they do, and it doesn't break anything. Like you don't write in the wrong place in the storage, or it doesn't break some invariance. So very important part of the Maiden design is the safe composability, where you have execution context and you can execute something in a private context, and then it can have some interface to the public context and so forth. So that's one of the main design goals. To go over some high-level components, I'm not going to go too much into details, but Maiden is a stack machine, so you have an operand stack very similar to EVM. It has its pluses and minuses. Register machines are more efficient in some ways. Stack machines are easier to encode instructions. In the ZK context, there's other options, but we decided to go with a stack machine. We have memory, read-write memory that is accessible. Again, not a big deal for your usual machines, but in the ZK context, sometimes you could implement write-once memory, and it's much more efficient for ZK context. This is read-write memory. It's a bit more constraints, a bit more complicated, but we decided that it's needed because people are more used to this memory model than to a write-once model. The other thing we did is, we have this set of chiplets, and this is important if we think about circuit versus VM-based execution in the ZK context. Circuits are going to be much more efficient by design because you only create a circuit for what you need. VM, you have some overhead, but the way you deal with overhead is you create these chiplets that is a specialized accelerators for specific circuits, and you can accelerate hashing, you can accelerate signatures, and so forth. So we have a set of chiplets that we expose in the VM. And then one other cool thing that we have is that there is an interaction between the host and the actual VM, and the host is an environment that you can define as part of regular kind of computer, whatever that you're executing a regular program. One nice advantage of ZK virtual machines is that you can provide this non-deterministic inputs via the host. So you can offload a lot of computations to the host. And what I mean by that is if there is a computation that is much more efficient to verify than to compute, then you can perform the actual computation in the host and then ask the VM to verify it. An example of this could be like square root, for example. Square root by itself is a fairly complicated computation, but you can compute square root in a machine code very optimized and then give the result back to the VM, and the VM just needs to do a multiplication to verify that square root was computed correctly. So that allows us to simplify a lot of computations. Okay, I'm gonna skip this. I think this is one of the things I want to cover. So we want to have Maiden VM to support many different languages. The way we've designed this is that we have Maiden assembly, and there is a Maiden assembler that does it, compiles Maiden assembly to kind of the code that gets executed in the VM. Maiden assembly is not pretty to write in, like it's not nice, and we don't want people to do it. So we're building a tool chain. For example, right now we're building the compilation from Rust. So we want people to be able to write Rust, compile it to WebAssembly, and then WebAssembly gets compiled to Maiden assembly, and that gets executed on the VM. We already kind of have a compiler working from WebAssembly to Maiden assembly. We're still working on the Rust part, but we want to make it more general. There is actually other languages that we could plug in. Like I'm a big fan of Sway language, for example, and I would love it to also run on Maiden VM at some point. And you can plug in there, like if you can compile to WebAssembly in specified format, you will be able to execute it on Maiden VM. If you can compile it directly to Maiden assembly, there's actually intermediate representation that I didn't show that is kind of crane lift based. You can compile to that, and those will be executed by Maiden VM. So we want to be support many different languages on Maiden VM. And yeah, I'll skip that one because I think I'm out of time. But this is kind of performance, and you can see that it doesn't run that fast, but it is good enough to generate most transactions, and then we're working on optimizing this. All right. I think I'm out of time. Thank you.
Thank you. Do we have some questions? If not, then you can just keep talking. Okay.
Can we compile circum circuits to this?
It's not designed for that. You would not necessarily want to do circum. So the whole idea of the VM is that you don't need to design circuits. So I would say you would either do circum circuits or you would use Maiden or something like that, because those are two alternative paths. Circum, I mean, you could do it. It probably would not be the best idea to do it.
Any other questions? We should just get you your own microphone. No?
So quick question. So if you go to slide one slide back.
Let's see.
Okay. So
I don't know.
No worries. So my question, because Polygon also has a ZK VM, right?
Yes.
So what's the performance gap between, because you're building a next ZK VM. So what's the performance delta in there?
So it's so the applications are different and the kind of execution models are different. So ZK VM, you are expected to be executed on a big server. So like right now we're running ZK VM on a server with 128 cores and half a terabyte of RAM and things like that. So this is the purpose, how you would run ZK VM, because you have the 256-bit arithmetic to deal with, you have cache and all of that stuff that is not very ZK friendly. Maiden is designed to be run basically on a laptop or a smartphone. So right now we can run most transactions for Maiden on a simple laptop. We estimate that for most transactions, you probably don't need to have more than between 4 and 8 gigabytes of RAM to execute them. You should be able to do it at least for now on a let's say 6 or 8 core laptop. You should be able to do it in under a couple seconds. Again, it's not quite apples to apples comparison, because you can say, okay, well, what if I break out EVM transaction to be a single transaction and try to execute it? Maybe it would be 10x less efficient, but you can do it with EVM because EVM is a global state, and that's part of the ETX. So you can't individually prove every EVM transaction and then combine them together. You have to have a single block that, because of interdependencies between transactions. Maiden is slightly different, where you can execute each transaction individually, and it should be our goal is to do it. At least for now, you should be able to do it on a laptop, and maybe in a year or two, you should be able to do it on a smartphone as well. You combine them using recursive proof aggregation. Yeah.
I got one more question for you.
Yes. I have a different talk at a different event where I explain how that would work.
Quick question: is this can you illustrate the difference between Maiden and Polygon Zero?
Well, Polygon Zero is a prover, right? So Polygon Zero is a prover that we're building for the POS chain. So they're different. So Maiden is its own VM. Polygon Zero is the proving system, like Plonky 3, for example, which Maiden may, probably will use in the future. So there are kind of different parts of the stack, so to say.
But the Zero can, be used to prove Maiden as well as the Hermes.
So Plonky 3 we would be able to use Plonky 3 that is developed by Polygon Zero to prove Maiden execution, same as EVM execution. So it's the backend prover that is responsible for actually generating proofs. It's not the instruction set of the VM. So you could use Plonky 3, for example, for proving EVM or proving Maiden and whatnot. Maiden is like a VM that rides on top of it. So Polygon Zero, it's not a separate VM.
And maybe just sort of a general question on Polygon, but you've got all these different solutions out there. How are they supposed to all accrue value to the Matic holders, token holders, if you will?
Yeah. So I mean, we have this vision of unified kind of ecosystem of chains where you can run different chains. Like Maiden would be one chain, ZK VM is another chain, POS, and then other third-party chains, so to say, that can plug into that. All of them will use some part of there's staking hub through which people may choose to validate this or add security to their chains, or there could be some fees that depending on which parts of the security model you use, you could contribute to the kind of Matic and things like that. So through that aggregation, Maiden doesn't have its own token or anything. So through that kind of aggregation, using shared proving and shared how should I say, staking kind of hub, that's how it will accrue back to Matic.
Thank you, Bobin. Give him a round of applause, please.
Thank you.
Thanks, man. Yes. Then I would like to invite on stage our last speaker of the day, Rahul from Stackr.
All right, how's everyone doing? I know we've had a lot of talks today. I know there's meant to be lightning, but we're in Istanbul. It's kind of raining. We're here for a crypto event. So what does lightning? Well, if the speaker works. So what does? What's happening? Not really. Can we go to the next slide if it's possible?
I think you're holding it upside down.
That would explain a lot. All right, so what does lightning actually mean? Well, apparently, if you hear a thunder crash, that means VCs are getting wrecked. And if there's a lightning strike, that means it's time for you to ape into DeFi protocols. And storm clouds means there's a lot of liquidity pools that need funding. All right, I didn't have many memes, so I wanted to do something fun or dumb. So this was it. And I did lie about not having memes. This is my final one. Basically, I am working as a protocol engineer and a product manager on the Stackr rollup that we are building. Stackr is a privacy-focused, privacy-centered first rollup. And unfortunately, that meant we had to let go of EVM and build our own kind of rollup architecture. But what exactly is Stackr? Over the last few years, some people have called up a public-private ZK rollup because we have a private state, but we aren't just a private rollup. We also have the public state, just like you have on Ethereum. We call a hybrid ZK rollup because we have both things. We call the ZK rollup because we're a ZK rollup like Scroll, Starkware, etc. But we do another round of ZK to enable privacy at the user level. Some people decide to call us an actual ZK rollup because in a normal ZK rollup, you don't actually hide much information. It's still kind of transparent. Others call us an encrypted ZK rollup, which is an easier way of understanding how we enable privacy. But how does this public-private blockchain kind of work? Because we have a lot of blockchains today that are private, but very few that can do both. Like I think Nick said from Fuel, at the private layer, we use UTXOs, so Merkle tree of notes, as we call it, basically UTXOs. And all of those things happen at the user level, whereas on the public side of things, we have private state, public state. The public state is kind of like Ethereum in that you have an account state tree model, so a giant Merkle tree that just stores everything, which is kind of similar to Ethereum, right? And of course, because we are a rollup, we can do L2 to L1 transactions just like you expect from a normal rollup. I've used the word rollup a lot, but I haven't said where we are, what you can do with it. So 2 months back, we announced the Aztec Sandbox, which is live today. It's a local developer environment like a Foundry, an Anvil, a Ganache, if you will. So you can just run the entire rollup infrastructure locally on your machine and start playing and understanding with this new era of blockchains that we are considering, where you can have privacy as well as transparency and combine all of them to enable this new kind of architecture. Just in the last 2 months, we've seen hundreds of developers and companies already building on us. And we have a lot of dedicated feedback partners that are helping us think about new standards, new ways of building things. But what exactly can you build? What are these features of this new fancy virtual machine or blockchain that we're building? One of them, as I've said, public state, public functions, but also private functions. So in the private function domain, the way you can think about it is a transaction might happen in the blockchain, but the only thing you'll know is that something happened. Or more clearly, someone did something in some state at some function of some contract. Privacy. On the public side, it's kind of like Ethereum, right? So you create your intent, your transaction, you send it to the sequencer, and then again, because you're a ZK rollup, the sequencer will execute the function, and then they prove it that they did it correctly. But the best thing about all of this is actually not just having private functions and public functions, but having composability, having private functions call public, having public call private. This lets you interweave both of the states. This lets you do many cool things. For example, if you're using Uniswap, you kind of want to know how much liquidity there is. You kind of want to know how much the volume is. That stuff should be public. But what you want to do should be private. So you can't just operate in a complete private model, which is why we have this seamless composability. To give you another example, MakerDAO works on liquidations, right? To liquidate, you kind of need to know the price that someone put in or how much collateral they put in. That's why you need both private state, but also public state. Similarly, on that note, you could also read historic public data. That changes the ways people can think about airdrops. For example, you could prove that at certain block X, you had a certain NFT all embedded into the blockchain. You don't need your own database. You don't need to write SQL queries. It's all a part of the blockchain itself. We also have account abstraction. Account abstraction is a bit of an overloaded term right now, one of the biggest buzzwords, I guess. What we mean by that at Aztec is you're not going to have any externally owned accounts. Everything is kind of like a contract address. There's no real differentiation between the two. But that also means you can add any kind of signatures that you want. You could do Face ID based signatures instead of having seed phrases. You could also just have seed phrases. In fact, you could also have nothing. So like you could just have a dummy account, just like signs whatever, without any encryption. You can play around with all kinds of things that you want. My personal favorite feature, though, is this thing called portals, which is, so you have a lot of, everyone knows about DeFi Legos on L1. Everyone knows about Legos in the similar way on L2. But we've not kind of seen Legos across L1 and L2. What I mean is, imagine a world where you could like submit a collateral of ETH on L1 and just mint DAI on L2, or do the reverse. Imagine a world where you could supply on L1, borrow on L2, and then kind of have composability across them, right? So you have arbitrary message passing that executes things on L2s. We have our own kind, instead of like not having approvals at all, there are sometimes approval is useful. So we have our own way of implementing that kind of short circuit some of the issues of approvals that we've seen on L1 over the last 5-6 years. And finally, as I said about historic trees, you could also have encrypted or unencrypted information sharing. This is very useful when you just want to pass data to someone, but don't want anyone else to know about it. And the way you build all of this is using our language that we call Aztec Noir. Some of you might be familiar, but Aztec is known for creating a ZK language called Noir, which is just a way for you to write your own ZK circuit. we have created a framework on top of that to create a smart contract language out of it. So if you're familiar with ZK circuits, notoriously hard to write. Everything in Aztec is kind of like a ZK circuit. Now it's no more. With Aztec Noir, it feels like you're writing a normal language. You don't need to think about weird ZK abstractions. It just kind of works in the same way Sway or Solidity or other languages would work. Finally, Aztec will launch decentralized. That means decentralized sequencers. That means decentralized provers. That means upgrades where multi-sigs don't actually control your funds and can't just run away if they have to. That's all. We're at the first step with our local developer environment called Sandbox. We're looking for people to build with it. We're looking for people to help us think about some of the open issues we have. You can find me on Twitter, or you can also, sorry, X, or you can find our docs in GitHub. Thank you so much.
Thank you, Rahul. Before we move on to the panel talk, we got time for one question. Then, just in time, sir. There you go.
Yeah, I wanted to wait. It's a tough question. Are you concerned about regulation around privacy?
So Aztec is going to be a censorship resistant, privacy first layer 2. The point of blockchains was to be completely decentralized, just so people can do what we want. And for that, you need to be fully decentralized, and it only makes sense to be censorship resistant. So we are doing this not necessarily for regulatory environments, but because we think rollups should just be decentralized. And we think if you're fully decentralized, censorship resistant, people can do what they want. But also if people, yeah, you can see all flavors of things. If you want, you can finally have regulations such as KYC that can be private, encrypted. So like that's something we haven't been able to do in blockchains because they're completely public, right? Now you can. You can store your personal data completely privately and still have whatever regulatory environments you want to be in.
Thanks. Then I would like to invite all the speakers back on stage. And David from Fuel. There you go. Give yourself a quick introduction. Is it on?
Hello, hello, hello.
Testing.
We're waiting on, is Raul from Arbitrum? Yeah. Hello, everybody. Ready for the last last event of the event. I guess we can do quick intros if anyone hasn't been at the talks. My name is David Myhall, and I'm at Fuel Labs, but I will be a neutral moderator. You guys want to do quick intros?
Sure. Hey, I'm Raul. I'm an engineer at Arbitrum, working on our VM that is compatible with EVM semantics.
And I'm Carsten Monk. I'm from the Katis Foundation and a board member there, but I also dabble a lot in the technical parts.
Awesome. I'm Nick, the CEO of Fuel.
I'm Rahul. I just gave a talk. Engineer and product manager at Aztec.
Cool. And so the theme of this talk is, I didn't even write it down, but I believe it is general purpose VMs versus custom VMs. I guess someone made the point that they're all in some sense general purpose VMs, but I think by that we meant kind of purpose built like blockchain oriented VMs versus environments that are more general purpose and taking those to be on a VM. And I don't know, to keep this interesting, I want it to be, I want it to be like a debate. Everyone's super nice here, but I want some like arguing or something. So I wanted to try to kind of like segment the projects here into those two categories. I mean, I kind of have my take on it, but I figured it's probably better to just, it's a bit of a spectrum. So for each of you guys, would you say you are a general purpose, do you fall on the general purpose side, or are you building like a specialized VM? I guess you can go first, Raul.
Sure. it's hard to say. I mean, our main thesis is that the EVM network effects, and when I say the EVM network effects, I specifically refer to the tooling built around the EVM, right? And what developers are used to, what applications are live today in production, what people are using, and we feel like we need to preserve those properties. And of course, like deep down, we're doing that through WebAssembly and through our runtime, which is a general purpose WebAssembly runtime. So I guess my hot take is really that we should just really preserve the compatibility layer and the network effects there. And underneath the hood, it doesn't really matter for us. We just care about efficiency and cheap costs and just speed.
Yeah, so for Cartesi, I think that we are quite a general purpose VM because we can run RISC-V, we can run Linux on it. And my definition of a general purpose VM is a VM that you easily can run Doom on.
That's a great definition.
Yeah, that's always the test of a good virtual machine. Yeah, so with Fuel, we're definitely a specialized VM, so not general purpose. And we went that route because we wanted to tailor the way the instructions work, the way memory works, the way storage works, the way the entire thing functions for the very tough and adversarial environments that blockchain typically presents. And so we wanted to build something that had the level of specificity and determinism and safety that blockchain would typically need. So for us, definitely more on the specialized side. Yeah.
Yeah, I guess there's a bit of semantic one. Generalized in the sense, no R is Turing complete. You could do what you want, but specialized, obviously, because we're focusing on adding privacy on top. So both.
Yeah, and from my end, I would say we're more on the specialized, much more on the specialized side. And I think, again, like there's different levels. Like if you talk about like general purpose, like there are like x86 type of general, then there is like EVM type of general, and then there is like even more specialized than that. And you can pick where you want to be in that spectrum. And I think, especially like in the ZK context, it makes sense to build something it makes sense to build something special, especially if you want privacy, because like that doesn't exist in any of the general purpose environments, whether it is EVM or x86 or whatever.
Perfect. I think that pretty much matched my mental model of I kind of had like Cartesi at one end, Arbitrum pretty close with being WASM based, and then Maiden is kind of closer to the other end, but then like probably Fuel and Aztec being pretty like special built VMs. I think sounds about right.
Yep.
Cool. Before we kind of unlock that, before we like kind of fully dig into our VMs themselves and kind of the different like trade-offs and decisions you guys have made there, I wanted to like back up a bit and look at kind of how we've reached these architectures. So obviously the dominant VM across blockchains right now is the EVM. We've been talking all day about kind of a lot of the different problems and challenges, but I'd love to hear quickly, like, what do you guys think is kind of the main challenge that is holding the EVM back that you think is like best addressed by breaking away? Because obviously there's a ton of network effects there. Like, why do we need to break away from the EVM?
See, so at the VM layer, I think we absolutely need to break away into more efficient execution methods. Like one of the biggest drawbacks is that in most implementations of clients today, the EVM is interpreted, right? So it's extremely slow compared to something that is closer to natively compiled. So like with WASM, we're able to do just-in-time compilation and get really fast results because it's just that much different when you're running something that's native to your machine than at the EVM layer. Instead, we want to preserve compatibility at the upper layers of the stack, right? Like the applications people are building, how they're deploying them, how they're interacting with them, that needs to stay the same. And can be gradually improved, and we have the ability to customize and do things a little bit differently, but we want to provide that option that compatibility is there, right? So with Stylus, we can do things, we can introduce a lot of fancy things that maybe EVM tooling doesn't have available, but we still support EVM compatibility. So people have the choice, and we think that's what matters for us. And yeah, so we want to innovate at the execution layer, but support and extend the composability layer.
Yeah, so from Cartesi's side, like the EVM certainly has its purpose and it's been proven in being absolutely fantastic for blockchains, or to some extent fantastic, and it's something that's there right now for us. But there was a talk earlier today where somebody was saying that like everybody knows Solidity, but this is a very narrow view on a very small sample of people, right? Like there's definitely more people out there that know JavaScript, right? There's people that know Rust, and I think that in terms of kind of like actual developer adoption, like I honestly think that EVM has failed in terms of actually getting developer adoption because there's so many people that wanted to get into blockchain, but they felt that this was it was like a mountain to climb. Of course, the security and so on, but you know.
It's a good hot take.
Yeah, I mean, so from my perspective, so I've been building with Ethereum almost since it started. So I think like 2015 or 16 was when I really started to post a lot of stuff. I've been using Solidity since version like 0.6, and I was using Aleth 0. So I don't know if anyone in the room goes way back to Ethereum's beginning, but you know, basically been using everything from Ethereum for a very long time. And I think fundamentally what I felt was all the time was that the Ethereum Foundation pushed off a lot of the tooling work to the community, which ended up highly fragmenting the solutions for just general tooling, and it lacked a lot of cohesiveness. And it took many, many, many years to get to the place that it's at now. And I think it held the ecosystem back significantly in terms of developer adoption, and we missed many, many good years because of it. And so I don't necessarily think that designing languages or tool chains for your VM is the wrong approach. I actually think designing the right tool for the job for the VM is the right approach. It's really great if you can do it. General purpose ISAs or WASM, et cetera, all interesting approaches, and they're really cool. But I think I just felt like in general, the tool chains and the languages and what was available for Ethereum was never really quite there, and it lacked a lot of vision as to how it would all function, which is very unfortunate. But still, the community, because of the values of Ethereum, what it was, it pushed through, and you know, eventually we got some pretty decent tooling and stuff like that out of it. But yeah, I would say that like for Ethereum's sake, there's a lot of room to grow. Yeah.
So I think there are like two reasons. Actually, one of them I'll steal from a panel I was with Nick last year, which is over the last 6-7 years, the way we've used blockchains have considerably changed, and new problems have come up, ones that we couldn't have thought about before. MEV, seed phrase, creating and managing accounts, always been hard. Many other problems that we're still talking about, scalability being one of them. So like creating your own custom VM would mean you can finally solve some of these. You can be opinionated about which solutions you want to solve. The second thing is innovation. We see like a lot of dApps now, there's much less innovation now in terms of like brand new architectures at the app layer than before. Creating a custom virtual environment with custom features would mean you kind of break people's mental models and enable them to think again like we were when we were kids. For example, somehow because everything's public, we've decided you shouldn't do identity. You shouldn't have real world assets, becomes much more problem. Maybe the bet for Aztec is when you add privacy, you can stop that. You could get identity finally on chain. You could do much more things in a much different way. So I guess innovation and just the inherent baggage of having EVM could be two reasons why we shifted.
Yeah, I would say basically there are probably a lot of deficiencies in EVM that are small and like, you know, kind of fixable, like dynamic dispatch and safety and all of that stuff. But I would say there's probably 3 main reasons why you may want to develop your own like instruction set or your own VM. The first one is EVM transactions are built in such a way that they're very difficult to parallelize. You want, like, if you want to scale beyond like a couple thousand TPS, you need to do parallel transaction execution, and you can get it with EVM, but it's like kind of like chewing glass to get it with EVM. The second one is privacy. Like, it's very difficult to get privacy on EVM, and even if you can, like with ternary cache and things like that, it will be more expensive to use privacy than it is to be non-private. And that model, in my mind, doesn't really work, because if privacy is more expensive than the other alternative, people are not going to use it as frequently. You want to make it so that privacy is cheaper option out of the two. So if you want to be public, then you need to pay extra, and then by default, many people will be private. And then the third reason, which is probably less of a reason now, is like, but at the time when we started, we were not even sure you could like practically prove a VM execution in ZK context. That was not like, now this problem is kind of solved. We have ZK VM and Polygon, which runs. Again, it requires a big server and all of that, but it is practical now. So I would say much less of a reason now, but at the time when we started, we didn't go with EVM because we just were not sure we could do it in a practical manner.
Awesome. I think that was a great background on some perspectives and design decisions. I want to jump into, kind of like breaking down these two different approaches. Nick touched a bit on, kind of the tooling landscape. And I think depending on which approach you take, you get a very different tooling environment. As Nick was saying, if you build a new VM ecosystem from scratch, you have to build a lot of tooling with it. It's nice you can have your tooling be cohesive, but it's a lot of work to do. Whereas if you use existing things like using Rust or Python or something like that, and your VM supports that, you get to tap into that ecosystem of tooling. But again, it might not be as oriented for blockchain. So I'm curious how you guys think about tooling, like which is the right approach? Why does it make sense to do one versus the other? And anyone's feel free to jump in. We don't always have to do round robin.
We don't, but we could. We could just do it again.
That's true.
Yeah. Well, I'll say, I'll start off. So for tooling, it's really perilous to build your own tools. We've been doing it for Fuel for the past few years. And, we're just getting to a place where I'd say it's almost, ready for everyone to use. But it's taken many, many years and a lot of work to get the tooling to a place that, the custom tool chains to get to a place that feels good for a developer. So building your own tools is really painful, and building your own language is really painful. Building your own stuff is very, very painful. But I would say the benefit is that once you've done it, once you've gotten to a place where you've gotten enough out of it, the benefits could be enormous because now you have a really tailored system to target your environment that really understands all the different contexts of your environment. And it makes things like auditing and debugging and really understanding the machine design of everything far easier. So it's a big lift. It's a huge job. But if you can do it, the reward at the end of it is fantastic. But of course, for general purpose stuff, I would say, using Rust and Wasm and all that other stuff has its benefits too. So, yeah.
Just one question. Would you prefer building your own tools or like letting the community build one?
Yeah, so I think with Fuel, we kind of saw how letting the community build the tools went over the past few years and decided to do some of that ourselves. But I think we're really just trying to get the tooling started and trying to get it to a place where you can ship really great performant apps on it, and then allowing the community to take that vision and then forward it. It would be maybe a better approach than having the community do everything, because I think that was the big failure with Solidity in a sense, was just like, there was very few people maintaining it. There was very little coherency in the tool chains. And again, I think it really hampered adoption a lot.
Yeah, I don't think that customized tooling as itself is a problem, because even if you're looking at, let's say, cloud computing today, right? Like there's customized tooling in order to, for example, deploy something to AWS, or different mindsets of doing computation, like let's say Lambda. And there's nothing outright wrong with that, but the challenge has always been that as you're also saying, that left up to the community, but essentially what has happened is that they have externalized the problem to somebody else, right? And letting them solve the problem.
Decentralization.
Yes, decentralization, but not in the good way, right? And I think that it's all about kind of like we're nowhere if developers can't use things, but at the same time, there's also a specialization to doing blockchain application. Of course, if you're building something that needs to handle high value stuff, then of course, similarly to how you would develop, let's say, secure enclaves or something like that for transactions, of course, you need something specialized for it, proper tooling and so on. But why does it need to be so damn hard?
Yeah, one interesting point about using tooling in a general setting is, and this potentially a problem, is the tooling from say WebAssembly might not be well suited for blockchain, or is it well suited, and how can we measure that, right? Are we trying to maybe fit like a square block into a round peg? And that's something to think about. However, by the WASM ecosystem has evolved so much that it enables things that we didn't think would be even possible. So something that was exciting about using tooling that is that is very public and used in kind of the Web 2 domain is that recently a developer wrote an NFT that they were able to render with the same exact contract code in the browser because it was written in Rust and compiled to WebAssembly. So we see these interesting things that arise when it seems like maybe the tooling might not match the domain perfectly, but developers find interesting ways of bringing it out to light. However, we do believe that by relying on the massive community and ecosystem that WebAssembly has fostered, we're able to reap a lot of benefits. It's hugely supported by the web standards committees, of course, by the different browsers, and we just get all of that for free from building on it.
I think in terms of tooling, there is like probably a spectrum of things you can choose, right? Like, and different approaches that you can take. One of the conscious decisions that we made for Polygon Maiden is that we decided not to build our own language, because while we are our custom VM and things like that, we will build a compiler that will compile from other languages. So we would much rather use Rust or maybe Sway or other languages, and hats off to people who develop their own languages. This is like, we decided that it's a monumental challenge, and kind of on the spectrum of how much tooling we want to build, we decide like we'll go up to the compiler, but not beyond that. But even building the compiler is like, it's a fairly significant challenge, and all other things you still need to, like with EVM approach, you get sequencer, indexers and like block explorers and all of that out of the box, which you probably still need to build for custom things. But yeah, I think you can pick and choose where on that spectrum you are and how much you want to bite off.
Absolutely. To push back, I guess I'll first push back on the pro build your own tooling side of like, in the EVM world, we saw we've gone from kind of Truffle to Hard Hat to Foundry, and kind of, maybe it's debatable, but I feel like each one of them was like a progression above the next. So Nick, you were kind of saying like, oh, when you leave it up to the community, it gets messy, but does that messiness not ultimately lead to like kind of the best experience versus like a top-down design?
Yeah, I think one thing that when you do your own tool chains and you do your own stuff, the issue becomes then you look at other communities and they might have advanced certain features that you just haven't even thought of yet. That's just a good idea, but you haven't even gotten to it. I think community development with the right setup can work for certain settings. Like Foundry, I think works really well because Giorgio's really set up how committing to Foundry works really well. But it's very hard to do in a community setting versus doing it by a single organization. And I would say that there's pros and cons to both. So you're not going to get everything. It's just like physics, But I think what you do get is when a single org at least starts it off, right? Maybe doesn't always do it, but just starts it off. They can at least make all of the experience coherent of developing with the system, all the way down from the language, every tool down to the language, down to the VM. And I think that kind of customizability is and control is very, very important for developers to feel like they can really get all the power out of your system versus like just using all kinds of general purpose tooling that wasn't really designed for that job and trying to make it feel normal when and everyone knows it's not. It's definitely not what it was designed for. So that's the way I would approach it.
I guess I'd push back slightly on some of the small things, which is like, when you're starting with a custom blockchain, etc., you have to create your own tooling from scratch, right, as the founding team for the blockchain network. But there's a very small line, like you could either make it completely like monolithic and have everyone has to use that, and eventually once the network is stable, you hope that community picks up and there's some smart people who can do it. I think the route we're taking is like modularization, not just because it's a buzzword in blockchains, but turns out it's just good in computer science, in the sense that you have this smart contract framework, you can build it into multiple different libraries, and people can use this one library, and then they hate your implementation of the other library, like your storage implementation, and they can just write that and swap in and swap out kind of thing is the route that we're planning to take there.
To kind of flip things around to the other side, if you're using general purpose tooling and maybe general purpose languages as well, do you guys see there being any issues with security, given that these languages and the tooling and things are often not made for blockchains, economic systems? Usually, they're made to run like web servers and stuff like that. Is there any risk involved in using general purpose like non-chain tools?
I think there's always a risk to using any kind of source stuff. Is there anybody here who's actually checking the checksum of the Solidity compiler when you actually download it? Right, that's a problem here. That's a problem that, why aren't we already doing reproducible builds of our tools in this ecosystem, right? Because we explicitly trust the Solidity team. Of course, there's a GPT signature or something like that, but why can't we go in and see on the actual blockchain that there's a, let's say, undisputed computation about that this Solidity code was built into it? I mean, with something like general purpose virtual machine, you can already now compile a Rust binary and get the exact same thing out. You can build a Docker container, you can build Solidity for it. So why aren't we doing those kind of things right now? It's all about supply chain, and if there's anything we should know about in crypto, is about the supply chain, because we get hacked all the freaking time through the NPM packages.
We chose WebAssembly because it's being battle tested in possibly the most adversarial environment comparable to crypto, which is web browsers and the internet. So standards committees and the different browser engines have put in a lot of thought, and companies are using WebAssembly in production in the browser today. So we leverage all of that. And because we only need the deterministic part of the WASM specification, we're able to constrain that even more. But agreed here that there's always risk, of course, especially when the domain can be a little bit different than blockchain from where this tooling comes from. Nonetheless, we chose technology that is being used in production outside of our own creation.
I guess one question too for the WebAssembly side regarding security is if with WebAssembly and general purpose languages, one really nice thing is it lets you bring in external dependencies. But do you guys see that as well as what's the security properties of that? How do we make sure that if developers are pulling in crypto libraries and stuff, that it's still running as securely on chain as like a crypto native tool chain?
We can't stop bugs in crypto libraries, of course. But yes, I mean, you can use things that are already heavily audited and heavily used. So as an example is, we deployed the BLST, which is a popular BLS signature verification library that actually Ethereum uses in production. And it's been heavily scrutinized. And it's, although it's written in C, for maximum performance, it has so many eyes on it. It has so many people trying it out. So it's also about educating developers on what to do, what not to do. Don't roll your own crypto, for example. But of course, if bugs come from those crypto libraries and they deploy them on chain, we can't stop those bugs.
And I would say you probably don't want to limit. I mean, if you limit it too much, it stifles innovation in ways like you want to allow people to bring in new signature schemes or new hash functions or whatnot, because it allows. It comes with a risk, and maybe you need to educate people to say like, okay, this is like standard or what or standardized, or we kind of like community has evaluated and like vouches for as much as possible for the kind of correctness of the code, but you're free to bring whatever else. Like if you want to have a post-quantum secure signature scheme, hopefully we'll go with something that is NIST approved, but if you develop your own thing, you should be able to deploy it. It's up to you. I would say I don't think we should be opinionated in that regard.
Yeah, I would say, I mean, using any tool has the same risks, right? Like, regardless if it's open source, unless you apply checksum matching, you don't know if you're actually using the right thing. We're writing a lot of custom cryptography for Aztec. We're using WASM, of course. I think anything with ZK in the browser has to use WASM, because crypto usually written in C++, Rust, and you have to put that on the browser. The one great thing about that, though, is you write your blockchain environment with a security-first mindset. I think weirdly in blockchains, like the current status quo seems to be you first write your dApp or application, and then you pause work for 6 months, then you audit it, and then you launch, as opposed to the standard practice, which used to be like you write, while you write, you test, and you have a security engineer that also does pen tests at the same time. So I think that's like the continuous like CI/CD kind of pipeline. The continuous pipeline of testing is way more important, because sometimes you just can't do anything, right? Like our founder came up with Plonk a few years back that is just custom. A lot of ZK rollups are using that. The only way possible is you either stop doing ZK stuff there, or you just continuously, rigorously security test, and of course do the audit. But I think the worst idea would be to just not do any security, write your application, roll up in our case, and then do an audit.
Yeah, I think one of the things that is also important to kind of like sometimes remember is that we, of course, in this business, we go automatically to cyberpunk-like security, right? Like the government shouldn't be able to take us down. But there's many, many blockchain use cases that is more about, let's say, smaller governance to some extent, where these kind of use cases might make sense. It might be they evolve into like some autonomous like organization over time, but does everything need to start there? Instead, we should be giving people the tools to actually make themselves more secure over time.
I think, Bob, you raised a good point about standards being a big part of kind of blockchain development, but including in relation to security. That some security comes from kind of the architecture of the chain and the libraries and stuff like that. A lot of it will just come from the community in terms of what tooling not just tooling, but like what libraries they use, what interfaces. I've certainly been a big critic of the ERC20 standard. Well, I guess how do you guys think of standards? How much should the the language, the environment kind of enforce these standards? How much should the community enforce it? How much should it be flexible to allow kind of like experimentation and different types of applications? What do you guys think about that?
I can actually start with this. This is sort of like a minimalistic approach, but like I think enshrining the least amount of things seems to be the way to go forward. If you enshrine a certain standard early on, new rollup, new application, you will encounter new issues, and then you kind of just have to sit through it. So like maybe a good middle ground is like putting out reference implementations in the terms of tutorials, because once again, you're building custom VMs, right? Like Arbitrum Stylus, you still need a custom, like you still need to have reference implementations of even ERC20s. Same for all of us here, actually. I think the best is like to get the community to come up with a standard, or even like think about what they could look like, and just have old school design decisions, design requirement analysis on them. But nothing, it should never require changes to the protocol, for sure.
Yeah, I would just say it really sucks getting to an architecture and then being a dev and then looking up how do I build a token, and it's not answered, like how the structure of everything should work, or at least what a reference implementation would be. So I think for certain things, standards are going to be really important, particularly tokens, particularly fungible and non-fungible tokens. I think defining some other standards as a starting point for any new tech, any new VM, or any new environment is probably the first thing that needs to get done. I think with certain architectures, like Fuel or Move, for example, assets are already native to the system. So it's really just how you standardize some of the metadata versus like the actual implementation. Like in that sense, it's more enshrined. But I would say that like it's incredibly important to define those things. Probably everything else is sort of up in the air, I would say. But I think certain key standards to launch are really, really important. Yeah.
Yeah. So in terms of standards, like if we're looking at something like RISC-V, it's a specification and the standard and how you do things, but it also comes with a boatload of test cases, right? I can actually confirm that my virtual machine is acting according to kind of like how it's supposed to be. Of course, there's the occasional kind of exceptions and so on. But for example, there's no such thing as, I don't know if there's, I might be wrong here, that there's no such thing as a very wide test suite for ERC20, how it's exactly supposed to behave, because at least I remember there's been a lot of mess ups in terms of like how different tokens are supposed to react to things. So it's not just about standards, but also about test cases, about how does these things evolve. And this is one of the standards, is one of the most difficult things to do in the world, because everybody has their own incentives. And I think that we can also learn a lot from kind of like how internet standards has been produced in terms of the IETF and so on.
Like how many funds have been lost to approve and transfer from,
Yes.
you know, like that's a good good starting point, Yeah, exactly.
I think my perspective on this is like basically to enshrine as little things as few things as possible in the actual like core protocol design. So like do not enshrine signature schemes potentially. Like Maiden doesn't enshrine signature schemes, doesn't enshrine basically anything. Like there are a few things that we specify, like because of the ZK context, we have to say like this is the hash function that you would use because it's the most efficient one in the ZK context. But aside from that, like we don't even specify like how an account has to look like. And my kind of our approach to this is that we want to provide standards right from the start. Like this is what a token contract looks like. This is how a basic wallet contract looks like. This is and a few other things. But then we'll provide a default signature scheme that you can use, but you can bring your own. But basically, you come up with the standards, but you should not be, or you should be able to like change the standards without breaking underlying or have to change the underlying protocol. So like if you want a different token standard that's still interoperable, like hopefully with the previous, like you have to define some things, but as fewer things you have to fix, the better it is. Like that's our kind of approach.
Yeah, I mean, to kind of like build off that a bit, like you're talking about, yeah, hopefully you never need to kind of, change core, like enshrine things as things go on. But of course, some features will be enshrined in a rollup. The architecture of a virtual machine will inherently enshrine some things, whether it's some cryptography or something like that. Like, and of course, the blockchain space moves very fast. My feeling is that right now the execution space is going to start moving even faster because we're kind of reaching maturity at the consensus layer. So, given like changes in kind of the whole ecosystem, we will have things like intents and PBS and stuff like that. How do you see like your architecture is being able to adapt best to the upcoming changes?
No changes to really adapt to from our side because we're purely just an execution change. As long as Arbitrums keeps supporting kind of the EVM equivalents as much as it can, then we should be fine. I think it's exciting to see just the new things that we can introduce while maintaining compatibility. So interesting things, and these might not be coming, but there's some ideas is we could implement rentable storage as something that we could do on Stylus while maintaining EVM compatibility for Solidity EVM smart contracts, right? So we have a lot of flexibility there. So like you said, consensus, things are coming to the consensus layer. As long as we support those, we're free to innovate on execution.
It's a cool idea.
Yeah, you give an example of PBS. So Stackr will be launching with like decentralized sequencing, and one of the first questions that we came up with when designing such an algorithm was, currently, if you look at validation on Ethereum, you have PBS that's not enshrined, right? Flashbots, and there is talks that maybe Ethereum should do PBS. It's not confirmed yet, right? And we were thinking a lot about, hey, should we enshrine PBS already because we know the issues that came up with the Flashbots relays, or do we not, right? For us, the problem goes a step further because we don't just have the sequencer, but we also have a prover. And then you go like, okay, so do we enshrine a decentralized proving mechanism at all? Or do we let the sequencer decide? So they could even give it to Gevulot or some other third-party proving marketplace, right? So some of the things that ASEC's done is, for example, on the private side, we don't have a VM. I think mine and everything is a VM, so we only have that for public. For private, we just don't have VMs or opcodes. We just use circuit proofs as a way to like tell the rollup that things were done correctly. For sequencer selection, we decided to do PBS. We decided not to enshrine PBS for the simple fact that it just seems risky. It's something even Ethereum is still considering. They aren't sure, and they've been live for many, many years at this point. But also means you can do many other things, right? Like once you don't enshrine PBS, you also mean that the sequencer could act like a prover, or that sequencer can decide to be lazy, just do sequencing, and give the proving side to a random third-party marketplace or just a friend that they know that does proving, kind of thing. So I think the biggest problem is like you don't know what innovation will happen soon, and you want to be future compatible with innovations that can happen which you don't even know about, and it seems like the best way for now to do that is like enshrine as less as possible. There are like many examples in the Aztec side, but yeah.
Yeah, I mean, in terms of enshrining operations, like right now, the Fuel VM has a few cryptographic operations. So SHA-256, KeyCAC, and a bunch of different signing curves, P256, etc. But in the future, we would look to actually just use an implementation of that on the Fuel VM, because itself, the Fuel VM is very, very efficient. So once we optimize things more and progress things more, we'd look to actually get rid of the enshrined things, in which case you can target the Fuel VM very much like you would target any WASM context. But enshrinement is important now just to move the process along, but in the future, we'd aim for that level of optimization. So I agree with the enshrinement point entirely.
Cool.
How would you remove enshrinement? Like, would you just upgrade the protocol? Would you like hard fork?
Yeah, well, so we're pretty anti-monolithic in terms of our thinking. So we would expect there to be many thousands of fuel chains and fuel VMs running. So over the time of people deploying more of those, you would have newer versions and newer upgrades. Yeah, with that in it. Yeah.
So just to follow up on that, but open for everyone, like when do you think is a good time to enshrine something? A lot of you guys have said like, well, you don't want to enshrine things because you want to be open to seeing the ecosystem evolve and figuring out the right way to do things. But I mean, a lot of you, maybe not all of you, would say at some point like it makes sense to enshrine something. Like most VMs have like crypto enshrined because it gives you some performance. Like, so when does it make sense, or does it ever make sense to like enshrine features like that?
So I think from a general purpose point of view, like if you're looking at it just from completely, let's say, how, let's say, different features kind of made it into CPUs over the years in terms of, let's say, SHA-56, 256 acceleration or AES encoding, something, it's when it becomes standardized enough and stable enough to actually make sense. One thing I also just wanted to bring up a little bit in terms of kind of like the discussion about, let's say, how do you deal in intents and PPS and so on, is that mental models help, right? For developers, it helps that they can understand that's something they already know. So for example, with a general purpose VM, like an actual Linux machine, that might have even, let's say, you can kind of visualize something like a sequencer, a little bit like a deterministic network interface, for example. It makes it easier for you to reason how it will these new technologies will affect your thing. Intents is basically kind of providing a solution, how to, let's say, actually make this execution happen. And I think that's also very important in terms of kind of like not just standard, but also like sharing the mental models of people. So it's easier to reason about, because like, I think, for example, let's say with Fuel VM, there's a very limited amount of people who can reason about what the effect of, let's say, PBS is going to be on it.
I would say, like, you probably, so there's like a difference between enshrining and optimizing for something. So enshrining in my mind is like, basically, this is the only way to do these things. Or maybe like, yeah, I mean, that's how I would say, but you could say this is not the only way to do things, but there might be preferred optimized way to do things, and you optimize for SHA-256 or for the signature scheme. Doesn't mean you can't use a different signature scheme to sign contracts or whatever else. It just maybe you haven't optimized and it may be a bit more costly. And then over time, hopefully, as like, the market or the use cases show you where it goes, you may re-optimize or rebalance some optimizations, but you like, in terms of enshrining, kind of the definition that I use, where you prohibit, like say, this is the only way, you should probably make as few choices of those as possible and just say, okay, this is the absolute minimum that I will enshrine. You can do other things, they might be more costly. And this is like, and maybe this will change in the future if the use cases shift.
Yeah, I think it also makes sense to enshrine once you know that you want a brand new feature that you perhaps haven't thought about just because you're building a brand new execution environment. But I would agree that there's a difference between optimization versus enshrining itself, for sure. Yeah, but like figuring out exactly when to enshrine something and when to not is like this billion-dollar question, or in our case, the sum of the valuations of all of our companies question.
I think when it comes to cryptography, especially on our VMs at the moment, I'm hoping at least we could get to a point where, like, some of us are talking about that BLS 12 for 381 signatures haven't made it to EVM. Is it really? It's really not expressive enough to actually, let's say, do this completely general purpose thing that should entirely be possible on the VM. So at least the benefit we have with our languages and our new virtual machines is that we can actually go ahead and add these new features that we actually need for our things and end up a standardization where it might eventually be a standardized feature.
Yeah, I think it was courtesy, right? That's not really enshrining fees at the moment. Like enshrining fees is something that, at least to me, and this is just my personal opinion, seems like such a complex problem. Like, how do you even know which opcode should be priced at what point? I mean, you could do benchmarks in theory, but you still don't know in what creative ways. I was gonna say weird, but I'm using the word creative ways people will use certain things. But I think fees would be a good example, right? Maybe you start off as completely non-enshrined, and over time you'd realize, Ethereum has done it, right? Where they reduced the price of call data like 3 times in the last 7-8 years or something.
Increase the price of storage.
Yes, increase the price of storage as well, kind of thing. But yeah.
There's another reason why enshrining is a thing, and I think it's different in the world of rollups compared to consensus protocols such as Ethereum. In Ethereum thinks about enshrining things sometimes to fix problems of incentives. So with proposer builder separation and what happens with MEV, there's this concept of a relay that's kind of the semi-trusted entity that can censor, create a lot of problems, and we kind of have to deal with it today. And by shifting it over into the protocol, Ethereum is trying to move that trust into the protocol itself, and thereby eliminating kind of these middlemen, right? So that's another reason, and thinking about that. And with things such as changing the data marketplace for Ethereum with EIP 4844, that's another example where the incentives are aligned, and Ethereum wants to acknowledge rollups as the scaling solution for it. And it's the first time that at the protocol level, Ethereum will be acknowledging that rollups are the way to go, indirectly even, right? But it's a way of shifting away, that off-chain incentive or those separate models into the protocol itself to solve a specific problem.
Awesome. I want to ask about interoperability, because we're building all these VMs. We've had so many different VMs talk today, but we all kind of want to exist within this this shared ecosystem, this shared economy. So interoperability is really important between different applications, between different chains. How do you guys think of interoperability, and what is the best way for a VM to ensure that it can be interoperable if it needs it? I guess there's probably the case that interoperability doesn't matter, but I'm curious how you guys think of it.
Yeah, well, happy to start. So with interoperability, I think how introspectable your chain is will be will be a big determining factor of how well it's going to, or how long it's going to last, basically. So, and what I mean by that is, if other chains can't get a good eye on what's happening in your environment, it's very difficult to build good tools and bridging around it, and so your chain becomes more isolated. So with Fuel particularly, we designed our VM to be very easily introspectable. So introspecting it from Ethereum is very, very easy, and introspecting it between Fuel VMs is very easy. One pitfall of Ethereum's design is it has a global state tree, which you have to traverse, and it also has these massive trees in general in smart contract state or just across the system, which are so enormous you can't actually use them on chain. They're really horrible, and you can't even use them on chain even with something like Arbitrum Stylus, because it's too much data. It's just way too much data to pay for. Like doing one proof would be like the cost of deploying a smart contract or something. So so basically designing for introspection, I think, is really, really important. And from the optimistic side, it's really just that everything is derivable on our side from the block headers, and so it's really, really easy to take a look at what's happened on the chain. But I think if Fuel did a ZK version, it would probably all be ZK related in terms of how you would do like shared introspection. But I could leave it to the ZK people to talk about that. So yeah.
That's a great setup. ZK people.
So at Polygon, we actually have like this kind of holistic take on interoperability, because what we're trying to do is have many L2s come together into single like interop layer. So like interop layer is a part of like Polygon itself. So like Maiden is going to plug it into interop layer. The KVM is going to be part of interop layer. Other chains that either within Polygon or from even outside can plug it into interop layer. It does have to be a ZK-based chain because like the interop layer, one of the tasks is, for example, aggregate the proofs from all the chains, prove that recursively, and just push one proof to Ethereum. So you kind of amortize the verification cost across many chains. The other thing in there is that you can move things, move assets and funds and whatnot between chains even faster than you can hit Ethereum. So like Ethereum, you need to submit proof like once, like the most frequent once every block, which is once every 12 seconds. Or more practically, you would submit it less frequently than once every block for many reasons. But if you have this shared interop layer, you can move things between chains even before they hit Ethereum because everything is proven to the interop layer. And then once in a while, interop layer goes back to Ethereum. But yeah, that's how, I mean, we have this, and it's big parts of it are still under development, but we have like LXLY bridge that allows you to plug in different chains. And we're working on like this interop layer as well.
Yeah, in terms of interoperability, I'll focus my discussion to just like interoperability with L1, just because we all are L2s. It's like so far what we've seen with rollups is they have this bridge that is like supposedly trustlessly bridging assets into layer 2, but that's where the interoperability seems to end. Like if you ever want to use, you see liquidity fragmentation because you see app devs literally having to redeploy everything all the way and then having to bridge all the funds and hoping to God that liquidity is enough for you to do your operations. I think we're doing something that we were inspired by with Devconnect, which was our previous product, wherein you could have like these Legos across L1 and L2 without having anyone to redeploy anything on L2 and just use like some kind of an L1 to L2 message passing mechanism. But as far as interoperability across other chains go, I think I was at a talk maybe 1 to 2 years back when ZK was just catching on, and people were talking about how the great thing about ZK is you could have these ZK light clients kind of thing wherein finally, you're not constrained by if a chain has light clients or not, as long as it is ZK provable. You don't need to do any kinds of sort of verification checks. You just create a ZK proof, and that's kind of like a light client at a high level. In theory, that should, although I personally haven't seen that play out in production yet, but in theory, that should mean you can finally have better systems of shared sequencing and everything else.
Yeah, I completely agree that kind of like light clients is the way forward to kind of prove machines to each other. But the thing about light clients and virtual machines talking to each other is that it's only between serious people, right? And APIs and interoperability, humans are horrible at developing these kind of things. And if we have, let's say, 1 billion app chains out there with different kind of things, I would personally vote for that whatever interface that we're making between these protocols, we let the AIs take care of it.
Awesome. I know we're getting towards the end. Do we want to do questions? Good. Does anyone have questions? Otherwise, I got one more to go. Anything? Okay. All right. So yeah, to kind of wrap things up, I want to know how you guys think. We all want to bring in new developers into the space. We've touched a bit on kind of how developers might perceive the EVM. So a lot of us are coming from the EVM world, but for like an outside developer who's new to crypto, new to blockchain, like how do you guys think they would perceive your project, and why do you think it makes that your architecture, your language, whatever, makes the most sense for a new project coming into the space?
The incremental nature is really nice, like showcasing people that, hey, deploy this, you wrote some Rust code that does this, let's deploy it, and you can actually interact with it, and thinking of the chain as kind of this backend where you can deploy your application, and gradually expose them that, like, hey, actually, this is on a blockchain, and you have access to a rich environment of composable APIs. So you can actually call like an AMM, and you can do interesting things. So showcasing to people like incrementally really what they can do is very special, and in existing languages that they're familiar with and speaking a language that they're familiar with is our approach.
Yeah, so I mostly agree, but I think that one of the magical things about the internet was the point where we could sit down with Notepad, we could write something horrible in PHP and actually start using it and uploading it to a server somewhere. And I think that we need to get back to the playfulness of blockchain. Of course, there's security and you need to train people to do things right. And can I help those kind of things? That's the level of ease we need to get back to.
But is Solidity not the PHP of blockchain languages?
Sorry?
Is Solidity not the PHP of blockchain languages, though?
No, PHP is worse.
Probably true.
So like COBOL.
Yeah, so I used to build stuff with PHP a long time ago.
PHP was my first language.
Yeah, yeah.
I do love PHP.
Long time ago.
Place my heart.
So yeah, I guess the way we think about the language experience is that you know, we could fund development of like an LVM compilation strategy to the Fuel VM and support Rust and C or whatever. We can do that, but we chose not to do that because a lot of those languages didn't feel right when you use them. So if you use C or Rust to target a blockchain, sorry, Arbitrum, but I really, really don't like it. It feels very wrong. It feels wrong because the construction of the compiler and the language is not necessarily something that was designed to target this particular kind of environment. Now, you can do it, and we are doing it, and that will happen. But instead, what we wanted to do was take the best parts of what we liked about Solidity and what we liked about blockchain programming, but also take the best parts of Rust too, which we thought was really well organized, and combine that into a single language. So our whole sort of approach to someone is that if you're learning blockchain, learning Sway is like a good gateway to Rust. And if you know Solidity, then Sway is a good gateway to Rust. But if you know Rust, then this is very familiar for you. So in a sense, trying to bring people a little closer. And in some senses, I think the Rust syntax is very familiar. So I know that a lot of other teams are using it, like Noir and Aztec. But that's how we think about it.
Yeah, I'd say, so something that I only learned after starting my career in ZK space is, even though a huge portion of ZK developments is clearly for blockchains, there is a very small overlap between people who work in ZK and the people who are blockchain devs. One of the easy lifts that we're planning to do is, so it turns out it's very, very expensive even today to actually verify a ZK proof on Ethereum. And like one of our ideas is, what if you could use Aztec smart contract language, which internally is actually just a ZK circuit, right? And that way you can onboard a lot of the ZK devs, and that way you can also onboard many people into ZK, which today can't because of how hard it is to write a circuit. I mean, it's actually insane. I have only written one or two, and I don't want to write anymore because of how hard it is. But I think on the other hand, it's easy to say that, hey, look, I want Rust to be my smart contract language because almost every dev, almost like a huge portion of software engineers know Rust. But at the end, when you try to put it for blockchain use, you end up creating your own like libraries and macros, right? That might be Rust, but when you read it, it's just basically your own framework. It might as well be your own language, at which point, to what Nick said, might as well design your own language.
There's a small pushback here in that, like there's a difference between like forcing people to use like a domain-specific language, you know, to write smart contracts for your application, compared to having a framework that is kind of community built and anyone can build different frameworks, right? So we provide an SDK, kind of like a lot of famous JavaScript SDKs back in the heyday when you would see new JavaScript frameworks like every day. And those are developed by the community, by people, and you know, you don't need to use it, right? Like we're not forcing people to kind of use that DSL. Instead, we provide it, but you know, the actual API is very low level. People can come up with better, more ergonomic approaches.
Yeah, absolutely. Plus, like doing that would also mean people can use standard libraries.
So I think the key to attracting, or two keys to attracting like developers is there are two things, and they're kind of in tension with each other. The first thing is you want people to use familiar tools. Nobody likes to learn new things. And the second thing is you want people to have fewer possibilities to shoot themselves in the foot. Like if you can provide something familiar that is also very secure and robust and reduces the possibility of bugs, that would be the ideal thing. But I unfortunately, those are frequently in tension with each other. You can't do that. So you need to pick somewhere in the spectrum. You need to, okay, we're going to build like super safe language, but then it's not necessarily very familiar, or maybe it's not as familiar as something else. Or we're going to allow general purpose language, but maybe like more ways to shoot themselves in the foot. I think like we picked a point on that spectrum where we would say, okay, it's we're going to go for multiple languages, and we're going to try to ensure safety at the kind of VM level, and you should be able to compile from Rust. And maybe it's somewhat familiar. I notice like you still need to have a framework and all of that stuff, but maybe it's somewhat familiar, and maybe it's a bit more safer than some other approaches. But like, it's kind of like in the middle, but I don't know if there is a right answer. Like people need both, and there is no, like, it's going to evolve over time where you get to a point where you have something that is both, but like it's difficult to get there right now.
Yeah, plus if you try to make a super secure language, basically means you're doing a lot of magic for a developer under the hood. More possible, ironically, paradoxically, more possibilities for shooting yourself in the foot.
Yeah.
Yeah, if there's anything I could wish for kind of like for these custom VMs is that you do a little bit like the stylus people are doing, and doing like a unsafe, a little bit like Rust unsafe, where you have a RISC 5 or something like that in there you can squeeze in there, or wasn't. It would make life so easier, and you can kind of like put all the dirty code somewhere.
Yeah, I think what I don't like about using general purpose stuff for blockchain is that it produces all kinds of very odd results sometimes that are not necessarily intended for your application. Like basically a lot of the compiler toolchain is optimized for CPU caching and not for blockchain optimizations. So already the compiler toolchain is like not necessarily optimizing for what you want, and then you're also in an environment where effectively like the language itself will work for a blockchain, but you'll never really get close enough. Actually going closer by virtue of a DSL feels more right. However, again, like both of these approaches I think are very valid. So I think using Rust and C and these other languages, you can do it, and it's being done. So it's great. We'll see what wins, I think.
And I think like this efficiency point is very important, because even like if you have something like that is easy to write at a high level, but if the compiler outputs inefficient code, like in our context, like efficient code is extremely important. People will go and try to write assembly and to make it more efficient. And this is like situation that you want to avoid from people having to go and write assembly, because this is like the worst of all worlds. Like you have no high level constructs, and you also can shoot yourself in the foot very easily. So
You're saying you're not a Yule optimizer?
yes, yeah. I mean, if you have to like go to that level, there is a failure somewhere.
That's where the best nerd cred is, though, being the Yule optimizer.
Yeah.
Awesome. Well, we are over time, so I think thank you guys so much. That was a great conversation, and thanks everyone for joining us here.
Thank you so much.
All right. So I might just want to say a few things just before we go. So first of all, to all the people in this room still, congratulations. You made it. You made it to the end of this. I think a lot of us might be jet lagged, and I understand that. And also there's a bunch of stuff going on. But first of all, like a huge thank you to Cartesi, the other host of the event. It was awesome. And also to all the speakers, amazing, and the panelists, etc. And yeah, I think what we wanted to do with this day was try to start a day about virtual machine design and bring as many teams as we could to talk about their virtual machine architecture. I think just a few questions before you go. So right now we did these like lightning talks. Would you have wanted those talks to be like workshops or longer? Because they were really fast. Like, do you want to do a raise of hands? Should those lightning talks have been longer? Like 45 minutes? No, it was okay. Okay, good. All right, lightning talks, good length. All right, great. Would you guys be interested in separate breakout workshops and stuff on virtual machines at any point? Yeah? No? Okay. All right. Just getting a feel for that. All right. I just wanted to ask that. Yeah, again, thanks for coming out, and it's the first one, but we hope to do more of these throughout the year. And I think 2024 is going to be the year of explosive, crazy virtual machine design and blockchain, and I'm really excited for it across the whole spectrum. So again, thanks for coming. Enjoy Devconnect and everything else, and yeah, awesome stuff.
Thanks, everybody. And please join us for a drink in the lobby.
Thank you. Yes. Yeah. Wow. Thanks so much.